Hello everyone, and welcome to the SIU National Star Party. My name is Hunter Miller from the Adler Planetarium, joining you down here in Carbondale, Illinois to me. And by my side is...
Bob Baer at SIU Carbondale. I'm an associate scientist here and the organizer of this Southern Illinois Star Party, which is the local star party going on here at SIU. And really happy to be out here tonight. What do you think of the weather?
Oh, well, I mean, we have got beautiful weather out here. That certainly is not any of the issues that we're troubleshooting, that's for sure. The weather is beautiful, clear skies, no winds, so that is a great starting point for us here. Now, to start off, I did want to talk a little bit about this in-person event that we have going on right now. And so tell me, I guess really to start, what is a star party?
So a star party, for us, it's a big public event. We put out a whole bunch of telescopes. We have, oh gosh, I don't know, like 20, 30 telescopes out so far. We let the public bring in their telescopes and their photography equipment and set up, but it's a little bit more than that. So we also have a big screen. We do presentations. So some of the faculty here at SIU are doing presentations tonight on the sun, the moon. We're showing a NASA Edge program later that's also going to be shown on the National Star.
Hopefully we are back online now. We went offline temporarily there, but I think we should be getting a stream going. I'm gonna give us a little second because I'm unsure if there was a buffering period or a delay between, so hopefully everybody's hearing the stuff that we're talking about, but hopefully that should be most of our technical difficulties sorted for the night. So we were talking about this National Star Party, introducing this, across the country, across the world element of this program. So, where are some people joining from tonight, Bob?
So we've got some live streams coming in from some of our DEB Initiative telescope sites, and I'm looking over at Brody to see which DEB sites are active tonight. Do we have? I know that Colorado.
Tonight, is that right?
So,
yeah.
So we've got multiple sites, and we do that so some redundancy, of course. We can you and those form, and as you mentioned, Planetarium and doing pulling in the light, and it's in events such can watch something if they're in a location that's actually clouded out, or they have, and so
well, I think another part that's great is whether they're streaming or not, I love that they're coming here for astronomy and doing here, right? Together, and we've got a crowd here tonight, but hopefully as on these sort of satellite locations can parties, and we can really make it there.
That's mention, and so especially like homeschool groups, people at home who teach their kids about the stars, experts themselves. So this is an opportunity. You can sit out in your backyard.
Oh yeah, we'll be showing you the map of the stars, and giving you some tips for on your own, whether you have equipment or whether you outside.
So guide you through.
I think that's a really beautiful sentiment. There's real truth to it, right? We're looking at something, and all the way across the country you can be looking at that same thing, or across the world, and that's so exciting. And with the planetarium, we do some similar live streams like this, right? That really started during COVID when we weren't able to do these in-person events, right? Show people views, and so bring those views. So important during that, getting over the world hear from us when we're back in this. It's such a new way with each other, share our community. Really expand beyond that area.
To bring, it's really cool to bring everybody into an event like this.
Right, exactly. Well, cover before we start getting into what we'll be covering tonight. And so coming up, SIU have been a really essential part of looking back at the eclipses that we've had and looking at all of these projects that have developed down here. After that, we're going to take some time to give everybody some tips for how you can observe at home tonight. We're going to give it a shot with doing some comet observing. That's one that I think a lot of people online will be familiar with. You know, C2023 A3 has been all over the news, just taking over astronomy news recently.
Yep.
And so I think that that'll be a blast to talk about.
Most people know. So I'm sitting here and I know what Hunter's talking about. I'm curious if...
Yeah, Purple Mountain Atlas is great. And so I think that fun thing to talk about tonight, and then we'll get into some night sky, different things with our.
Cool.
So thanks so much. I think we'll have you back for the end of the show later. Stuff and enjoy. Yeah, thanks so much for coming over. Hello everyone, and welcome back to the National Star Party broadcast. Joining you from here in, well, I was gonna say sunny, but it is getting a little darker outside, so maybe a dimly lit sunset Carbondale, where I'm joining you from this evening. Looks like things are working a little better now. We had some more technical difficulties, made some switch outs, but I think things should be working a little more effectively now. So I'm going to keep rolling with the show, chat with you guys about all of the different things that we're going to be talking about today, and get started talking a little bit about from today. But I wanted to start with a few views here. Now, these are a couple of different views, and you'll notice that they look different. Layers on display here today. On the right here, this is a white light view. So if you have ever a telescope with a solar filter in the front, this is the and expect. Sorry, my apologies. Still working on figuring everything out here. Sorry if I'm a little stuttery here for a minute. And so we have a couple of views here of the sun. The one on the right is really the more solar view that you. So this is with a white of a standard displaying the photosphere of the sun. And what this is this is in that we can see. So the name will tell you that, right? Photosphere, meaning the furthest in that we can see. And so we've never seen anywhere closer inside on the sun. The rest of the sun is a bit to us, actually. On this layer, we can start to see really interesting features. Some here, those are all circles that you see across the surface of the sun. If you look really close, some of those spots towards the edges, like where you see right here, you'll see areas around the outside. These are higher energy areas around the sun. What is causing these? Look at this big ball of a ton of magnetic activity. Alrighty, sorry. Oh. Alright, sorry for a second, and I do apologize if the video is really buffery here right now. I'm sorry about that. We're dealing with some internet issues here that are a little bit difficult. Talking about this is the furthest, and these sunspots are twisted fields that are preventing solar energy from getting out. Photons are not able to escape it, making them then cooler to us. One on the left is a very different view. This is something that that is called the chromosphere, higher layer of the sun that is only visible using very specialized telescopes called hydrogen alpha telescopes. Now, these ones are a little harder to come by. These are not filters that you can very easily add to a typically getting texture that you can see in there. The sun is very, very active, higher mile here, and we're able to see that using filters. Pointed to see this hydrogen line. That hydrogen is an emission for hydrogen gas at a very particular temperature that it doesn't reach until it gets to this higher layer of the atmosphere. So being able to see these different layers of the sun is fun. I love doing solar observing. Of course, we're pretty limited during the daytime when it comes to telescope observations. And so the sun is a really fun one to observe, and it's very, very dynamic and constantly moving, especially recently as we have been reaching solar maximum. So this means of about 11 to 14 years. It's not always exactly the same amount of time. The sun, big swing of these different patterns that you see, really how much it is producing, how much it's sending our way, all sort of top. Now, at the peak of a solar maximum, you can tell with how active the sun has been, all of the visual activity that we can see of sunspots, lots of prominences, but also some effects of that down here on the ground too. If you've been catching any of the aurora region, that is thanks to that solar maximum that has been going on. Now, it hasn't been a big year for observing the sun for us. It's also been a big year across the country, and particularly this has been a big year that NASA has been focusing on the sun. Oh, geez, that was not the right slide. I'm going to skip ahead a little bit. This has been the Heliophysics big year that NASA has been putting on. That will conclude really soon with the solar probe's close approach, which will happen on December 4th. And so this will be investigating the solar corona. It will be learning about the source of these solar winds. You might think, oh, the sun is so bright, it's so large. We know everything there is to know about the sun, right? Not really. And we can see there's is ever 30,000 miles. With all of this talk about the sun's energy, how much producing out there, I wanted to talk about an activity that you can do at home that really demonstrates the power of the sun, right? The sun's really special in astronomy because it's the one thing out in outer space that we really feel, right? You have to feel the heat time it provides around us. This activity that I'm going to show, which you might have gotten a little sneak peek when I was scrolling through the pictures there, seeing some of that stuff here, but Today we're going to talk about this activity will really demonstrate those UV rays and how they are reaching us here. So you only need a few things for this. The first supply you'll need is shown here on the screen. I used leaves for this. Really anything flat will do a really good job, and something that is opaque, something that blocks sunlight. That's going to be a very important part of this. So I, in the fall spirit, decided to collect a few leaves that I thought would work well. Now what you're going to want to do is you're going to want to lay these leaves out on some construction paper, is what I used here, and you want it to be pretty dark. Now you can find sun print paper, so what we're creating are sun prints, using the power of the sun to create an image on a sheet of paper. If you buy that specialized sun print paper, it will allow you to create a more distinct image, but today I was just using construction paper when I made this because I figured that's available at home. And I will note, you want to use a dark color. That will definitely stack your leaves, any flat object. And then before standing inside with a window where the sun is extra heat as it passes. Today, putting a cover out and using that to amplify those sun's rays that we're getting. Now, I think this is literally an old window that I just happen to have sitting around. Plastic wrap, or you can tape your objects down and literally tape it to. Next two images, I want you to pay close attention of the construction paper. Picture of what was left behind, right? So this is a fun activity that is super to demonstrate really here on the Earth every day. Back to the Heliophysics big year. There's one particular that has been a real of this year. So we first have the Parker Solar approach now, but we've had stuff going on for an entire year already. If you're located here in this, but I think we're of 20 during totality. Today I wanted little video that is a recap of the festivities that happened here in Carbon for Eclipse. Decade 17 eclipse happened right here. And so at NASA Edge on Carbondale for the eclipse. And be back.
Outside look at all things with the best of the 2024 solar eclipse.
It was great to be back at here in 2017. This year that we were actually able to totality for more than 4 minutes. It was amazing.
I was amazing. We weren't, not only were people there to witness the eclipse, we had astronomers and students, telescopes, getting data and actually giving people through the telescope and during totality. It really was a special moment for all those who were there to see the eclipse.
You mean the people in attendance at Saluki Stadium, because the university had activities across the campus for people about the total solar eclipse. It was all part of solar partnership between NASA and the university, brought in all around to talk to us and to talk to the people in Carbondale about the total solar eclipse.
Yeah, and it really is about physics, and the eclipse is great, but we also had a chance to talk to Noor Rawafi, who is actually the chief scientist for the Solar Probe, which is the premier heliophysics mission for NASA and the Johns Hopkins Applied Physics Lab. Let's check it out.
When we launched 2018, You invested 1.4 billion doing nothing. Time solar probe. And the reason for it is the sun and the corona are extremely complex. To start with the basic state of the corona and try to understand as the complexity builds with math. So we started at solar minimum, now we are at solar maximum. We basically have a full half solar cycle. What the sun can do.
So brilliant plan all the way up.
Let me say, it was not really planned. It was kind of coincidence. It's a happy coincidence.
Well, and that's important for people to know. When you're going to be able to launch and be able to get data. So get the data.
Absolutely, and the sooner you get, you just jump on it. And that's the case with solar probe, with solar orbiter, with basically any other mission. We want to get it up there as soon as possible. But it happens that for Parker Solar Probe, solar orbiter, and DECIST, and basically in the we got the three biggest solar projects almost coming.
Parker Solar Probe they can compare it to down on.
Again, are the luckiest on the universe. So basically, Parker Solar Probe is close to the sun, but on top of that, have solar orbiter is almost on top of it. Yeah. So in an hour or so, of the solar corona, the solar probe and solar orbiter are somewhere on that image there, and they will be data that the solar wind flying from the sun and flying through them, which solar orbiter has coronagraphs on it. Will provide us another eclipse. Orbiter, and it's just unique.
Well, it's interesting because, like in case, like with when you today we're along the different vantage points. We've got partial here, and we've got total in some places, and we move along. That's like what you guys are doing from space. You kind of get that different view. How important is that for not just Parker Solar Probe, but other heliophysics missions?
Is extremely complex and is enigmatic. Many measurements as possible for different locations around the sun is always and will provide us more and more about this mysterious region of space that affects ways. So having is as possible on the sun, it will be helpful. The total solar eclipse is definitely one of them. So it's going to be extremely helpful for us to understand the physics of and how it affects on Earth.
Now, for you as a physicist, someone here seeing all these people, as we talked about, witnessing enthusiasm, soaking all that, what would you say to them? What are your words that you would like to share with everyone about this total solar eclipse today?
I think everybody should probably recognize the privilege we have with our Earth, with our moon, and with our sun. If you think of it, we have a single moon. Saturn has 146 moons. And the probability for a total solar eclipse is pretty low for Earth. Luckiest to the exact position to have almost the apparent size of the sun. And when it's on the sun, it covers. And there, the solar corona bursts forth in all its majestic splendor. It's fantastic. Imagine we did not have the moon, or the moon was not in the right place. We would not have these total eclipses. The discovery of the corona itself might have taken way time than humanities did. And think of it, all the studies all the physics we did, all the research we did about the sun and solar activity that's happening in the corona might have taken more time to discover it. But having the moon exactly in the right place, it's actually, it's a privilege for us.
Well, I tell you, I feel extremely lucky to be here. We're clearly very fortunate as a planet to be able to see these solar eclipses. Noor, thanks for being on the show. I tell you, we got a lot of stuff from Noor here, and we're very privileged as well. Now let's check out another video about our total solar eclipse. Gina, we're super excited about the Heliophysics big year. And of course, it's really interesting because you have had an annular eclipse,
Yep.
a total solar eclipse coming up. There are auroras. There's the Parker Solar Probe closest approach later this year.
Exactly.
All these events, it's almost as if you guys planned the big year with all these things.
Have more activity. We have more solar flares, more coronal mass ejections, and some of these are directed towards Mars. So we can analyze how these events really change the Martian atmosphere and contribute to its escape to space. And right now with MAVEN, dust season at Mars is starting to pick up. Mars dust season and solar maximum at the same time. One thing is that it touches on all different aspects of science. It touches astrophysics, and of course earth science as well. So when all these things are happening, we try to really our lessons from heliophysics.
I know how important space weather is and how things astronauts and even here on Earth. Do you help with data keep our roads safe and operational in terms of space weather on Mars?
As a matter of fact, we do. So what we do activity, and if we think that there's something that could, impact any of the robotic missions at Mars, we alert them to this. Some of the highest energy particles coming from the sun, they can reach the and some of the Mars rovers have a way to measure that. So we like to compare our observations on Mars with what. Okay.
Can you give us an idea of what the weather is going to be like at Carbondale for the eclipse? I need a guarantee that there's going to be clear skies and no issues.
I wish that I could control weather. That's one thing to right when choosing eclipse is what the percent average is. Now I'll be here. I think there's a small chance of clear skies, but we'll say fingers crossed. Yeah.
Well, hopefully. Clear skies, you'll have clear skies.
Yes, definitely.
Well, the crowds are going nuts here. Carbondale at SIU and Saluki Stadium. Bob Baer is with us, and Bob, it's amazing. I'm afraid to look up. I know it's not quite ready yet, but tell us, what do you expect here at the eclipse today? Good weather.
It's good weather right now. We have clouds, so totality is going to look just a little bit fuzzy to us, a little bit hazy, but we're moments away from seeing the diamond ring here.
I thought we saw it.
I think we got about 1 minute.
Okay, 1 minute away. Now, today we're having longer drop.
I felt the temperature drop about 20 minutes ago even, and the wind picking up a little bit. And I think, we have 4 minutes and 9 seconds here, so it'll continue to get cooler. And we got a lot to look at in the sky.
I'm very excited. I'm looking up when I can.
This is the start of it. It's dark over here. It's light over there.
This is amazing.
Coming.
Crowds are going nuts. We're about to get word that we're at totality. Oh, you can see the planets. The crowds are going nuts. This is crazy. Bob, this is amazing.
Here we go.
Don't look at the sun yet. It's not quite totality, but you can still see some of the planets right away. Oh, wow.
There it is. Diamond ring.
Diamond ring. Wow, that's amazing. It's amazing. That is awesome. Look at that. Oh, and wow. Bob, that's amazing.
Wow. That is huge. So we have some prominences. I think we want to go look through the scope.
Look through the scope. I'm going to walk over with you as you talk through the scope.
See that prominence at the bottom of it?
Yes, at the bottom. There's a prominence. I see it.
Wow. I keep looking
I
for
can't
Mercury,
believe the clarity. It's so much darker than 2017.
It's gorgeous. And what's awesome, we have 6 telescopes running back here, capturing data, streaming this.
And that's a big important part here. This is not just capturing image to share with people watching the show. You are actually capturing scientific data that can be used by scientists everywhere.
We are, and we've seen totality across North America so far in massive land. Now we're experiencing it ourselves, and we'll experience it after this on the Jumbotron from the other DEB sites.
It's like the most amazing Eclipse train you could ever ride on.
Wow.
And you know what's interesting is the crowd is quieting down. They seem to be experiencing the moment, taking it all in. A really special moment here. There's the diamond ring. There's the second one. Oh, snap. Oh, that's amazing. It's like it was scheduled.
Yeah, somebody had the timing right here. Oh my gosh.
That's amazing.
We will see shadow bands again here.
You hear the crowd. Everybody's excited. There we go. What an amazing moment here at Saluki Stadium.
Oh my gosh.
With Bob Baer and 10,000 fans, all loving every moment of it. Let me just tell you right off the bat, Troy, good to be back, but everybody's a little bit still in the throes of the afterglow of the eclipse. I know we were down on the field, but where were you watching and how was it?
So last time in 2017, I was down here with you guys and we watched it just here in the grounds where we are. And it was funny because in 2017, it was a lot less of an effect than we had this time. It wasn't as dark, it wasn't as cold, and we saw the last 10 seconds. But this year, I was able to go to the top of the Saluki Stadium roof, and it's all white up there. So we got to see the full 360-degree panorama of a sunset.
Wow.
And the most amazing thing I saw this time for the first time, and this is my 5th eclipse, by the way, probably right up here with the best eclipse I've ever seen.
Nice.
This was amazing.
Nice.
We saw shadow bands. It looked like you were at the bottom of a pool and water ripples were just going everywhere across the roof.
And isn't that somewhat due to it's like a flat, clear, clean surface, so to speak?
Yep, and it makes it really prominent when you see it. It happens right at the edge of totality when you're coming into the eclipse and right as you're leaving. It was amazing.
Yeah, I tell you now. How about? I'm very curious about this because I've been saying for a long time that what's really amazing about an experience like this, obviously the eclipse is great, but the feel of the crowd, all the emotion, all the intensity. You're up on the roof now. I know there were a lot of people up on the roof, but how was the response from the crowd being from that particular vantage point?
You know, I was geeking out so much when it was going on. I sound a little bit like Daffy Duck from the cartoons. I'm like woohoo, woohoo, like the whole time. And
I heard that.
And I turned into the person I hate the most. That all they do is repeat what they're seeing. Like nobody else can see it. And I'm like, Bailey's beads, Bailey's beads, Bailey's beads. And I finally caught myself and stopped doing that. But there was an emotional response upstairs on the roof as well. There were people crying, laughing. I mean, I think what happens is all of your senses are being affected all at the same time, unexpectedly. And it really was moving just to get everybody's reaction.
You know, it's interesting you say that. You talk about the different senses. This is one thing I've noticed at NASA and with other scientific missions. It's almost like in the same way, like having science missions flying, looking at that data from one point, people on the ground looking from another point, all along the path getting different data points. It's like what's really cool about this. It's kind of that unifying moment between all disciplines, all walks of life, everybody just sort of dialing into this one moment. It becomes something really special.
It really does, and it reminds me, and it really blew me away in some of the experiences I've had, not only eclipses, but any solar alignment that you're a part of. We've gone to Chichen Itza, we did a webcast there, and we got to watch El Castillo, the stair-step pyramid, and during the equinox, there's a shadow effect that looks like this giant serpent shadow goes up the side of the building, and we got to see that, and it was overwhelming, the emotional response of the crowd in the audience when we were there as well. And then when we were in Hovenweep, New Mexico, I think you were there with us, we got to see some of the eclipses, or not an eclipse, but we saw some of the equinox and alignments there. And what was beautiful about that is you see daggers of light going across petroglyphs and rocks in the southwest just on that day, and you feel like I am connected to the mechanics of this universe at this moment in a way that I'm not normally feeling.
Yeah, especially in that case with different
people groups. I mean,
Yes.
Not just indigenous folks, but over time, like
Over time.
that had practiced looking at these interesting astronomical events. Thousands of years before we were here.
It is
so
moving.
it really is impressive.
That is such a good point, because when you're looking at a petroglyph, which is where ancient peoples pecked designs into rocks that are still in existence, you can still see them. And when they are still in the exact place they need to be for solar alignments and light and shadow effects to hit them in an exact way, you realize you're, like you just said, you're not only connected to the universe, but you're connected to people throughout history and time who were standing right where you were standing.
And it's kind of interesting to think of some indigenous people looking up at the eclipse and being blown away. I don't know what their language would call geeking out, but I'm sure it existed in some form, and it had to be amazing. I tell you, this has been a great day. I got to be honest with you, much better than I expected. At various times during the week, Franklin, we really looked at the weather and we were very concerned, but thankfully everyone here got to see a good show, a very awesome total solar eclipse.
Yeah, and it didn't look like there was one empty seat in Saluki Stadium.
That's correct.
The crowd was boisterous.
Yes, yeah, that's a great word. I like that.
Yeah, and it was just a pimple-raising, just chilling event, and I am so happy that I was blessed to be here.
Right, and you know, we just have a lot of people to thank, because this process started years ago. It actually started back for 2017 when we did the eclipse the first time. We knew this was the crossroads of the eclipse and that it was possible that we'd be back, or at least there would be another big event here at Saluki Stadium. But I got to tell you, everybody involved came together and helped put together a very good show on a very fortunate day weather-wise. Great event for anybody interested in astronomy.
Absolutely. So it's going to be, I believe, 20 years until the next total solar eclipse here in the United States. But if you had the opportunity to make it to Carbondale in 2017 or 2024, your once-in-a-lifetime event, you were able to see it again.
That's right. Now, one thing I did want to say, just important safety message. You know, we focused on safety, solar, watching the eclipse safely, but these glasses, if you treat them well, if you don't put them in your leave them on your dash or something like that, they will last a few years, as long as you don't scratch them or tear them or damage them, or, like I said, leave them exposed. But you want to make sure that next solar eclipse you encounter, the one here in the United States might be 20 years, but if you're traveling abroad in the next year or so, make sure you have good, safe glasses to do any eclipse viewing. Because I think, Franklin, I don't know, maybe I'm not right, but I think we might have inspired a few eclipse chasers here in the audience today.
Well, I'm inspired.
I know, right?
If my treasury was on point, I think I would be able to travel to some of these remote locations for the upcoming total solar eclipses around the world.
I will say this. The next time I travel to go see an eclipse, I hope that I have the support that we had here with the folks at SIU, from Bob Baer and Harvey. These guys, I mean, I tell you, they went to the nth degree to make sure we got everything that we needed. They prepared us in terms of knowing all about eclipses and how to get the imagery right, exposing us to the DEB Initiative, all these telescopes, all across the path of totality. So I kind of feel like if I expend all my resources to go around the world, I hope that I can do so with a group of people like the people we worked with here at SIU.
And I'm with you. It's been a great time. I enjoyed my time here. We're about to wrap up and go home and see our families.
That's right.
But it's been a great time. Thank you for your hospitality at SIU.
That's right. Thanks to everyone. You're watching NASA Edge.
An inside and outside look at all things NASA.
Hello, everybody. Welcome back to the live broadcast from here in beautiful Carbondale, Illinois. I hope that you enjoyed the Best of the Eclipse little broadcast from NASA Edge. I know Harvey and me were just talking about how it was bringing back some memories, right? It's such a special day, huh? So you may notice, well, one, I got my coat on now. It's a lot darker here. It's getting chilly, hitting the nighttime hours of our observing. But before we jump all the way into the nighttime stuff, I wanted to bring on a very special guest this evening, Harvey Henson. Harvey, do you want to introduce yourself a little bit? Tell the folks why you're joining us tonight.
Sure. First, thank you so much, Hunter and Adler Planetarium, for being here back in Carbondale again.
Oh, we love it down here. We love it down here.
We do.
Harvey.
We love you here. It's like our solar family. And so yeah, hi everybody. I'm Dr. Harvey Henson. I'm a professor here at Illinois University, hosting this National Star Party. I also, so I'm a professor in geology, geophysics, and then science education. But my day job is directing the STEM Education Research Center. STEM, everybody, is science, technology, engineering, and mathematics. I'm sure you all know that, but I have to point that out to some. So STEM Center is what I do. Yeah.
Nice.
So.
Now, you are also the lead on this SolarSTEAM project, is that right?
Right.
So SolarSTEAM that has been really involved in the eclipses and this broadcast tonight, of course, we're on the SolarSTEAM YouTube channel. So can you tell us a little bit about the SolarSTEAM project and how you got involved as a lead?
Right. So thanks for pulling me out in the limelight here. Usually I'm behind the scenes doing all those things that a good director, a good principal investigator would be doing. But so shout out to the SolarSTEAM team.
It's a big team, a lot of helpers, right?
Amazing team. Hunter, you're on the team. Michelle Nichols is on the team. Adler's one of our key partners and collaborators on the STEAM team. But yeah, this is a dream team. It is a group of astronomers, scientists, heliophysicists, NASA scientists, a lot of experience. I mean, I kind of feel like an NBA coach, you know, who has the honor
like coaching the dream team at the Olympics or something.
Like, all right, guys, you know what to do. Just do your thing.
Didn't mean to call myself a part of the dream team. That was an accident.
I think I said that.
Maybe I was somebody in the reserves or something.
It's very, very appropriate. There's some heavy hitters on there. We have Troy Klein from the Parker Solar Pro project at Johns Hopkins University. Let's see, and I've already given credit to you and Michelle at Adler, but
and the whole wonderful team here at SIU.
I'm going to save the best to last here, but no, I'm just kidding. So Lou Mayo, who's been a longtime NASA scientist and contractor, astrophysicist, heliophysicist extraordinaire. Let's see, NASA Edge. Right?
Yes, of course. We just saw the broadcast from
Blair Allen, Franklin. I mean, the whole crew. Ron Beard. So shout out to all you guys. Come back to Carbondale as often as you can. And then, of course, the whole SIU team. Dr. Corey Brevik is one of our co-Is, and then Bob Baer.
Yeah, so we've seen Bob Baer on the stream already tonight. Corey will be joining me afterwards as well. So I mean, we're getting the whole crew here.
Yeah, so that's kind of a rundown of the SolarSTEAM team. I mean, I want to shout out to Carla Berry, who's in mass media and communications here on campus, and she's been doing so much with her students. They're amazing. We have so many talented students. Chris Mandrell. I mean, I could go on and on, but
I know. Well, and you know, one thing that I really love about the SolarSTEAM project is how it's got such an interdisciplinary approach, and we've brought so many different people together, all under, of course, one big thing in the sky, the sun, right? And so the big focus for your guys' project for you know the last decade almost at this point. I guess I don't know if SolarSTEAM was going on all the way back at the 2017 Eclipse, but you know, it's really been a continuation of this eclipse hunting, right? Doing this eclipse research, and I take it you've done a little bit of eclipse chasing on your own, right? I mean, you said yesterday at dinner you've got 3 total eclipses under your belt, right? And so I think that counts. I think that counts.
Thank you. Some other people, you know, say wait till you get 20 eclipses, then you're really an eclipse chaser. I'm like, I can't wait that long. I'm probably not going to live that long. So I'm going to start with 3.
Yeah, that's a great start.
We're making plans
to
we'll go to Spain, and then we'll probably be somewhere between Morocco and Egypt in 27, right after 26 in Spain. But we're already making plans for 28 and 30. I mean, so
the eclipse fever is undeniable, you know. I mean, I had a picture here that I was going to pull up just to remind everyone of the majesty of the total eclipse.
Wow.
And that beautiful corona coming in view, how wonderful it is. And it really is what drove this project getting really kickstarting, and, you know, what has now allowed it to expand into even more things like this nighttime observing that we're doing here tonight,
Right.
and bringing this National Star Party to folks online. It's a really exciting project to be a part of.
It is, and I guess if we celebrate all the people involved, all the scientists, all the experts, but if I can speak for the team, our objective is the engagement and education, because as you just saw, eclipses are life-changing. They're transformative.
Right. Absolutely.
They're that natural phenomenon that is in all play. I mean, you don't have to be STEM. You can be STEAM. That's
right. Absolutely. I think it's something that you really see. It brings so many people to astronomy. So many people gain an interest in astronomy because of these total eclipses. The amount of people that I knew in my personal life that were asking me about it, while it was going on, who had never talked to me about stargazing before, right? Yeah. Seeing the reach that has and how it brings so many people together is really wonderful.
It does, the holidays, we get together and celebrate holidays and things like that with the family, and sometimes we get into those discussions that remind us why we don't see each other all year round. But with eclipses, we don't have that, right? We're all the same.
Right, it's your second family, your eclipse chasing family, right? It really does build a strong community, and that's something that I think that has really come up a lot of times in the show tonight is the community around astronomy and observing, and how important that is, right?
You mentioned eclipse chasing, and I think for my wife Angela and I, what we've enjoyed the most, besides the few seconds or the few minutes, depending on how long the eclipse lasts, are the people we meet before, during, and after the eclipse.
Exactly, right? It's so special.
We have friends all over the world now.
Exactly, I know, it's remarkable. I had people come up to me after the total eclipse back in April when I was here in the stadium, who hadn't met before in my life, and were coming up to give me hugs. I mean, it's that real emotional connection. It's so hard to describe. You have to experience it to really understand it fully, I think. Well, I wanted to ask you a little bit about is, outside of your eclipse change, another thing that you've done a lot at is center. And really being involved so deeply in science outreach. And I think that is so much of what we're trying to do here tonight at a Star Party, right? It is about community, but it's about outreach and science as well. And I want to hear a little bit from you, like, why do you think outreach is so important to the STEM fields? Why do you love doing that work? Because a lot of scientists, they get stuck in the research and they really love that stuff. But to see somebody that is so passionate about outreach is exciting to me.
Thank you. I appreciate that opportunity. Yeah, the STEM Center's mission is to advance STEM literacy, right? To get people of all ages, especially young people, interested in understanding and making sense of the world around us. So obviously, total solar eclipse or a star party is the perfect opportunity.
Great opportunities for it.
This is what we do. A big part of our mission is service and outreach and education, partnering with educators, formal, non-formal. But yeah, we're also a research unit, so we want to know, how did things work and why did they work, and how can we do it better next time. So research is really that, and that practical approach to understanding how our outreach and our education activities and events work. So yeah, we'll be gathering data on this, and we'll be understanding how to do it better next time.
Nice. Well, yeah,
STEM Center is a part of the people that do that behind the scenes. So thank you for having me here.
Of course. Thank you so much for coming and talking with us, Harvey. We really, really appreciate it. It's been a joy getting to chat with you, and it's always a joy getting to come down here to Carbondale and visit. So that we grow these things. I mean, party here has become an annual event and has really taken over the community, right? Getting hundreds of people out every year, and now we hope that this National Star Party can really help do the same. And so it's exciting to be able to share this with everyone. All right, well, thanks so much for coming out and joining me, Harvey. I really appreciate you coming on. And I'll catch you out there after this show's over, I'm sure. Unless you're resting because of your tough day of field work that you did on Saturday.
I'll tell you more about how that went.
All righty,
radioactivity in southern Illinois.
Wow. All right, well, So that's a sneak peek. You'll have to come to one of his other events to learn about that. But yeah, stop by, Harvey. Have a good one.
See you.
All right, now with that, that concludes our portion of the night. You can see it's really starting to get dark here tonight, so we're gonna jump ahead to doing some of our nighttime observing and talking about how you can be doing nighttime observing wherever you are across the country as well. So my next guest that I'm bringing on is Corey Breivik, who I think is nearby somewhere. Oh, there she is. Sorry, it's really hard for me to see past my studio lights here. Yeah, come on over. Yep. Well, hello. You already have gotten a shout out in the stream, just a little from Harvey. So everybody started to get a little introduction to you. But Corey, do you want to go ahead and introduce yourself? Joining online?
Yeah, so I'm Corey Breivik. I'm a professor of astronomy at Southern Illinois University.
That's a wonderful start. Now you are so much, of course.
Oh, that's kind of you.
But that is a title at least to give.
Yes.
Now I know tonight here one of your roles at the Star Party has been really helping guide people in observing the sky and knowing what stuff is out there tonight.
Yeah, and it's just getting dark enough to be excellent.
Exactly. We're just starting to get dark enough to really see those things popping out in the sky. So I thought this would be a great time to bring you on, talk a little bit about the things that folks at home can naked eye from their houses, and then of course we'll move on to our telescope views after that, so we can show people some of the more slightly harder to view targets, right? So, want to start by doing a little bit of well, almost exactly what you're going to be doing up there on the screen soon. Going through some star maps, talking a little bit about the things that we can view in the sky tonight, and talking to folks about ways that they can learn a little bit more about the night sky, because Stellarium is a tool that is so useful for beginning to learn the night sky, right? So it is this big sky map that really gives you a comprehensive view.
And you can access it for free, so that's huge. Right?
Exactly. That's why I always love to recommend Stellarium. It's free. There are a few features that you might have to pay for, but they have so much available to you for nothing. You can get it on your phone. These screenshots here are from Stellarium Web, their web version. They have a computer app as well. Tons of ways that you can access the night sky.
Yes.
Now, the first thing I wanted to start talking about while looking at this as well, you can see this is my let me make sure I get it right, my western view tonight, taking a look at the things that we'll set a little bit earlier this evening. So I wanted to start with talking about some of these naked eye observing targets, some of these solar system objects we'll see tonight. So I see a couple on this screen that stand out to me.
Yeah, so well, Venus, right, is the first one that like pops out.
Right.
Right, it's like one of the most commonly reported UFOs out there, right? People see Venus and they wonder what it is because it's so bright.
So bright compared to everything
wherever
else.
you are, if the sun is just set recently, if you go look west, you're going to see this really bright star. It's the first thing that pops out for most people. That's going to be Venus tonight.
Yep, and then another very hot topic in the news recently, which we'll get the chance to observe a little bit after we talk about this, is the comet that's been taking over.
Yes.
We see its full name written out here, C2023A3, but recently the comet has been plenty for everyone to know what you're talking about.
Yeah,
right?
that's what I've been calling it, is the comet.
Exactly. That's certainly a good name for now. Now, if we hop over to the other side of the sky, over to the east, now this is a view around the current time for here in Carbondale. Now, what is important is, I'm sure folks are joining from all over the country, and the sky might be a little different there. Our time zones are very different. If you hop into Stellarium on your own, it'll automatically track your location.
Right, but for anybody in the U.S., if you look towards the east, Saturn is going to be very prominent.
Yes,
and so
absolutely.
if there's a really bright-looking star, how high it is in the sky will vary with your location, but Saturn's going to be one of the brighter objects in the eastern sky, a little bit south of east.
Yep, and the later we get into the night, it'll be moving more into that southern sky, be getting higher and higher. It should really stand out. There's not a ton of bright stars in its position in the sky right now, so it's really easy to spot. And then as we get a little later in the night, we see some even more interesting targets starting to rise. This is about 9:30 here in Carbondale tonight, seeing the moon coming up, which has been making the news recently because of its super moon status that it was in.
So which, people make it sound like it's gonna be huge, right? Like it's closer to to us. So it looks bigger, but it's not taking up the whole sky. It's
Right, right.
Bigger than normal.
I think the size difference can be up at how much it provides a little bit of light pollution of its own,
Yes.
right?
And now if you're hiking in the dark, it would be a huge help.
Exactly.
So.
I know when we were doing our test the other night, it was really helpful for seeing while we were wrapping up shop at the end of the night.
And tonight, you'll notice on here, Uranus is pretty much behind the moon.
Right.
So seeing Uranus is not really going to be a viable option because you're pretty much staring at the moon.
Right. It also comes up here on Stellarium because it is one of the planets, and so its name pops up quickly, but it is a very dim target in the darkest skies in the world on a new moon night. Maybe you could spot it.
And
maybe.
without a telescope,
Without a telescope,
it's pretty hard to see.
It's really, really tough. But we do see that Jupiter is just starting to rise this time of year. Later in the winter, it'll be a little bit better for catching Jupiter. But if you're a night owl and are going to be up past midnight or so, it also
or
shines
even
really
in
bright.
like another week when the moon has moved away from
That's
it'll
true.
be better. Like
That'll
it's just
definitely help.
awfully close to the moon tonight, and the moon is really bright.
Now, looking back over here on the west side of the sky, I also wanted to provide a view a little later in the night with some of these constellations that we're seeing tonight. So I know one that stands out to me here is this bright triangle of stars that isn't necessarily a constellation but an asterism, but always really stands out to me. We call it the summer triangle, so it's getting a little lower in the sky for this season, and that can start to guide you in seeing a few different constellations.
Right, and if
What
you
are some
go
of
out
yours?
around sunset, right, it's pretty much straight overhead.
Right.
So it's some of the Vega particularly is really bright, and it pops out really early.
Now, I know last night you were also pointing out the Sagittarius constellation.
I'm a big fan of Sagittarius.
I could tell that was one of your favorites.
Yeah, I really like that one. I know he's supposed to be an archer. I think he looks like a teapot.
Especially the brighter stars
right,
really
the
give
really bright,
teapot tipping over.
Yes,
Yep.
and the cool thing about that is the Milky Way. If you're somewhere dark enough to see it, the Milky Way is the steam coming out of the spout of the teapot. But the other part that's
I
fun
love
with
that.
Sagittarius is you're looking towards the center of the galaxy. So I think it's a cool constellation, but I also think it's cool that you can't see that far. There's too much dust in space. But that is the direction of the center of the Milky Way.
Oh, and I love how that, you know, when I look at the sky, I think one thing that always really helps me like place myself in the universe is thinking about the spatial relationships between all of these objects, how they relate to each other, and you know, like really what you're looking at and why you're seeing what you're seeing.
And I think that's a really good way for people to learn constellations is to pick just a couple and learn how they're connected to each other. So when I see, you know, a certain, like if I see a Sagittarius, I go looking for Scorpio. Now Scorpio is set, but if it's earlier in the summer, they're right beside each other. And so I know them as a pair. Or if I find booties, then I go to Corona Borealis, and then I go to Hercules. Like I know them in a set. I don't tend to just start looking for one of them. I learn them in chunks.
And you know, it really does depend on your location too. One thing that I always appreciate so much when I come down here to Southern Illinois, coming from Chicago, is just how many more stars there are out there, how many more constellations you can see. So many of these are ones that I never mention when I'm in the city because we can't see any of the stars, right? There's really only a select few that you can really make out there. And down here, it's such a busy sky.
I also enjoy how much the Big Dipper moves with latitude.
Oh,
right?
absolutely.
You know, when you get near the Canadian border, the Big Dipper's a lot higher in the sky.
It really is high in the sky.
By the time you get down here, it's almost skimming the horizon.
Right, especially now when it's on the lower path of its orbit. You know, it's always technically visible in different areas of the sky as it's you know, nearer to that north star, that point that the whole sky rotates
But here in
around.
Southern Illinois, it clips the top of the trees this time of
Right,
year.
exactly. I was shocked that just last Wednesday I could actually see it from the observatory that we have at the Planetarium. It was sitting right over the skyline, and I could still make out all those stars in the Big Dipper. And we also have lots of fun constellations to the east, which are some constellations that we're just starting to see for this year, ones that we haven't really been spotting throughout the summer. And so it's really excited to have some of these. I mean, some that stand out to me, which I'm shocked that this one doesn't have a name here. On here, but Cassiopeia
that's
here.
kind of a big one.
I know, and it's got such bright stars, a very
And
distinct shape.
It's circumpolar, so it's always visible.
Yep.
So if you can see the Big Dipper on the other side of that same part of the sky, that W or an M, depending on how it's rotated, right, is really prominent.
Right, and then some of the other ones that are exciting here. I mean, I see the Andromeda one mentioned. I only give that one a mention because I might be taking a look at a particularly notable target in that constellation later
But I like
tonight.
Pegasus because it's that
Oh.
huge,
It
great,
is really
big
big.
square. And so once you know how big it is, that can be a fairly prominent constellation.
Absolutely. Now, you were talking about learning the constellations a little bit, and I brought some activities with me tonight, and one that I think really helps with learning some of those constellations is you'll be able to see it here. Let me switch to our big view here. This is a little constellation finder that I was working on making back in my hotel room earlier, actually. A lot of these activities were done in my hotel room. And so in my little picture here, what you'll see is I got a printout of the Big Dipper because it's one that everybody's so familiar with. It's one that's always up throughout the year, right? And how you can make this is get one of those printouts. Got my little printout here with me. And then you'll want to create this little frame for it. So what I have here is, I used an old manila folder and cut it up, right? And then I think this is maybe a transparency sheet that I'm using
going old
here.
school.
Old school, you might not have those at home. You could always use
Saran wrap.
Saran wrap would work
Right,
great,
you could use a
exactly.
piece
Yep.
of Saran wrap.
That's been my backup throughout the program today. If you didn't have a glass panel, it was Saran wrap. That works well too, but the old projector sheets are nice and sturdy. Now the next thing you'll do is I actually overlaid these together, and I marked on my sheet where these different stars were, right? And so now, once we get back outside and we're out here on a dark night like tonight, might be a little hard to see with all the dark backgrounds behind me, but I can take my sheet that I have here, hold this up to the sky, and find those constellations in the sky. So I think this can be...
Which is smart, because I think one of the challenges is when you see the picture that you pull from online,
Right.
it's always oriented a certain direction, but that does not mean it's that direction in
Right.
the sky. So you might
Throughout
have
the
to
year,
rotate it.
it's spinning around that spot, right? It can be hard to catch. And sometimes when I come down here, I struggle because there are so many stars, And so having something like this can be a great way to start learning some of your favorite constellations, or maybe spotting some of the more difficult to find ones, like some of the zodiac signs that are a little dimmer.
Yeah, the zodiac signs are not always the best constellations.
A lot of them are
They
pretty
were
hard to
chosen
see.
because of their location.
Exactly.
And some of them are very dim. So pick a few, learn a few, then learn a couple more, and then learn a
Yep,
couple more.
Exactly.
Don't
A
go
lot of
out
them-
on a march and be like, I'm going to learn 50 constellations tonight, because
Oh,
you
no.
won't remember.
Exactly, and this is a good way to take it slow, pick some of your favorites, and really build up that knowledge over time and slowly. Now, in astronomy, we often have cloudy nights too, so I brought lots of activities with me just in case. And one that I think is fun for on those cloudy nights that you can always do at home is actually doing some constellation projection
Yes,
here.
those are
So
good.
you can see I've got all of our different materials lined up here, and they're pretty simple ones, right? Honestly, my flashlight was a little overkill when I was trying to take all these pictures. I actually couldn't use it because it was too big, and I had to switch to my phone flashlight, so that works great too. But otherwise, just a marker, a push pin, and a little cup.
Yep.
And have you made some,
I have.
some constellations in a
we
cup
did
before?
this with the Cub Scouts recently, like
Nice,
within the
nice.
last month.
Right, so exactly
fun.
all of these steps where we've got our marker set up to go, and using this might be nice to give you your little guide to what you're going to be looking at, where we're marking it out. And what's our next step here, Corey? What are we doing
Well,
next?
now you got to poke holes.
Exactly, right? So here I am with my little push pin poking holes through there. Of course, if we've got any young viewers joining us today, maybe grab a parent. Don't want to make sure we're not using anything
And the
too
great thing
sharp.
about this is you can use any cup. It doesn't have to be the little ones. It
Oh,
could
absolutely.
be big ones.
I actually found this
any
one was a little
size.
too small when I was trying to
Right.
fit it on there, so some big ones might make it
But yeah,
even easier.
Anything, orange juice can, right? You can be creative.
Exactly,
Whatever's
right.
lying around your
Right.
house.
These are
Dig
nice and
through your
easy
parents'
to-
recycling bin. You'll find something.
Right, empty container from something like
Yeah.
I don't know, sour
Styrofoam.
cream or yogurt
Yeah.
or something. Yep, styrofoam. Lots of things can work great. And you can see now you've got those little holes poked through. When you shine a light through, it projects it onto the wall. I was gonna try to maybe let's see if we can. Do you think we'll be able to pull it off on the wall behind me here? Let's find
Yeah, we
out.
got a black
I don't know
background.
if we've got a black background. You might be able to spot it on camera. I don't know. Oh wait, here. Let me make our view big here. See if you can get it in sight.
Oh, right. Yep.
Can you
yep,
see
yep,
it there
yep.
in the
You can
middle?
Totally see it. It's right there.
There you go.
Yeah. Very
So that's
cool.
a good way when you're missing your favorite constellation on a cloudy night to get some of those views.
And it's fun because working with kids, because you can isolate a single constellation and they can see it without all the other stars.
Exactly. You know, down in Chicago, it's pretty easy. We really, outside of the constellations, you don't have many other stars out there, right? We only have a few bright ones, but
the darker it
here,
is,
there's
it almost
so
makes it
much.
harder to learn the constellations.
Right, exactly. You've got such a busy sky above you that you can get lost sometimes. Well, if you want to stick around for some comet chat,
I always love to talk
talking about
comets.
next. But I know you do have some stuff happening soon, so I don't want to keep you for too long when you have.
I'm good till the top
other
of the
talks.
hour.
All right, good till the top of the hour. All right. Well, I think that it would be a blast to keep you around for a little bit, doing some comet talking, and maybe at least for this portion where we'll be talking about how folks can observe the comet at home, right? Because while it is getting dimmer, still visible in the sky, and there's some tips and tricks that you can use to view it a little bit easier. So I first wanted to start by going back to Stellarium and really focusing in on that comet location here. So, I mean, you were mentioning Venus earlier, and how is that a really important part of trying to spot the comet?
Yeah, well, I think the great thing is if you can see Venus, the comet is higher up. So if you can still see Venus, you know you can see the comet. It definitely hasn't set yet.
Right.
And it's going to be in that part of the sky. Now, it's not too close to it. And this is where Stellarium is awesome, because it will point out the comet so you know what part of the sky to look at.
Exactly.
But look west, see Venus, you're facing the right direction.
Yep, and you know, another really great thing that we were doing a couple of nights ago to work on getting some good views of the comet, and when it is, you know, getting kind of dim now like it is, we were battling the full moon the other night when we were out here, was snapping some shots with your phone. So you were experimenting a little bit with this as well, so capture this comet.
Yeah, so I didn't see it very well the other night. Like I was trying to that part of the sky and randomly, blindly taking pictures in that zone. And then I'd pull in and zoom into the image I'd taken, and I actually got a beautiful picture of the comet, but it's not really because I was aiming at the comet. You can use your phone to figure out what part of the sky to look in, and then
exactly right.
Kind of randomly
help
look at
give
pictures.
you some reference, right? I mean, one thing that I liked about this picture that I took the other night is that it didn't just include the sky; it included the ground too, and that can always be a really helpful way to recognize where things are. Is knowing, all right, I need to be looking right above this particular branch, right, or this particular tree, and so I think that's a really helpful way to spot
And then
it.
once you get it in your phone, you may be able to see it with your naked eye. Now that you know where to look. It's pretty faint. You need to be somewhere fairly dark, but your camera won't have anything special to get these images.
Now, you know, phones do these days, you know, adjust their settings to the condition. It's like a longer exposure of that area of the sky.
And I think mine was doing 3 seconds.
You were just doing 3 seconds, and you still got. Yeah.
But I also, when I zoomed, me a better shot than when I was. So.
And exposures, keeping your hand steady out.
Take a deep breath.
Yeah, I'm a little bit of a shaky person, real shaky hands, so with phone against it, you know, so it can be behind a table maybe to lean it
on the railing.
Exactly, a railing. That's great. And if you have something to lean it against, and that help.
Yeah.
Now, this is from a couple of nights ago, but one that I wanted to offer is that we a live view of the night that I wanted to bring in here quick. Yeah, coming in from one of our telescopes just off to the left side of me over here. So this is a live view of the comet, and wow, look at all of that beautiful detail that you can see, the stars behind it. Looking at it this lake the other night through the telescope.
Really cool.
That is
I mean,
incredible.
the amazing is even this, you're not seeing the actual comet, right? The chunk of ice is buried in that really bright blob, but it's coming off the ice and it's nucleus. So still don't actually see the vision.
We're really seeing the evidence of the comet,
seeing
right?
all the gas and dust that's coming off the comet as it vaporizes.
Exactly. So this bright in the middle, the long tail extending out of it, all this gas and dust that's pushed away by the solar radiation, straight from the power of the sun that we saw earlier. I love getting to see details in there.
Yes. If this object was way out past Jupiter, it wouldn't be this really cool tail because it would be too cold. But we're only getting this because it's in the hot part of the system.
Right, exactly. I think that's fantastic. about the journey that this comet has taken to make it. Right? And I wanted to put this image that shows a little bit of the orbit, right? This orbit. So this is focusing more on the inner solar system, right? We're only seeing the inner rocky.
Huge.
Exactly, right? These white circles that we're seeing that are all in kind of this flat disk are these inner planets. And look at where that red line is coming from, right? So this is one of these long period comets. Maybe has never made it. I have no idea.
No, I think the last said maybe 80.
Yeah,
approximately.
So nobody was around to document that for us,
we have
really.
no evidence, just looking at the orbit. But the other cool thing with the orbit is it's coming it's coming from below and going.
So a lot of the objects that we think of with the solar system is a real flat plane like you can see here. When we get these comets coming from these far out regions of the solar system, they end up being on way more different orbits. Great example, almost perpendicular to the plane of the solar system.
And from the Oort cloud. Right? It sent us.
That's one of my favorite things about whenever I tell people about the Oort cloud and this sort of repository of these comets out in the outer solar system is that we are only there because we've seen comets making this long journey here.
This is our evidence
exactly
that allows us to draw the conclusion that there's so much more out there.
Getting to see comet. This is the first comet that I've ever gotten the chance to see naked eye before, actually. I've never seen a naked eye comet. I know NEO-wise was similar brightness of
I didn't get to see that one.
I didn't catch that one ever, and I was only a wee boy back in the days. And,
now I'm older. I remember Hale-Bopp. It was very cool. But it's been a long time since Hale-Bopp was here. So.
Yeah, that was all the way back in 96, 97? Yeah, right around there. And so, you know, we're due for another really bright one, and I hope I get the chance someday to see something as magnificent as that. But this one has been great, and getting to catch it has been a real joy. Now, one other thing that I wanted to talk about, we call it a comet because the name is complicated, right? And so I want to talk a little bit about what all of that means, and because it's actually super informative and tells us a ton about this comet, right? So starting with that C designation, is those reserved for these long period comets like this, ones that have periods of greater than 200 years. These are pretty much all the ones you've never heard of before, right?
They don't come around, right? They're not our common visitor.
Yeah, so something like Halley would not be considered that because it comes around much more frequently than 200 years. It's kind of a vague designation, right? But it is one that starts to give us that information. Now, 2023 refers to the year that this was discovered. And A3, this is the one that always throws really easy. A refers to the first half of January is when it was discovered. Okay. So it goes all the way through, 4 letters of the alphabet of each month. And it was the third comet discovered in that
half of January.
Exactly. You start saying it all out, and you're like, oh man, this is getting complicated.
Joe's right. This comet's been. We knew about it in 2023.
2023,
right? We're constantly learning new stuff.
And I think also these kind of very calculated names are really common in astronomy, and it's because we are discovering so much these days, right?
Because there's so much out there.
There's so much out there.
So much.
And as our technology grows better and better, as our tools allow us to see more and more, that's only
and as new stuff comes near us, right?
Right, exactly.
This one had to get near before we were like, hey, something cool is coming.
Exactly, and you get the idea, right? This Oort cloud is so far past the Pluto, way past the Kuiper belt, right? It is way out distant parts of the solar system, and the strange orbit of this one really shows us, it's a sphere of these comets surrounding the entire solar system. There are so many bodies out there, and all it takes is a little disturbance to send them on a path heading this way to alter their orbit and make it a little.
One of the ways we think they got out there was getting gravitationally disturbed. So early in the formation of the solar system, this little chunk of ice probably got too close to Jupiter or Saturn and got booted way out there. So he's been kicked around kind of a lot.
this very well may be the case again, that this could, you know, having ventured this close to the sun, this could be at the end of its time in the solar system. It very well could have gathered up enough speed to launch it all the way out of the system.
Or to at least curb its orbit so
Interstellar
that
object.
it's on a new orbit the next time we
Right,
see it
exactly.
in 100,000 years or
It's complicated out
Yes,
there, right? There's a
yes.
lot of stuff going on, a lot of stuff pushing and pulling on each other.
Right.
There's so much
everything
activity.
with gravity, so it all tugs on it.
And then the last, which is now based on observatories that discovered it. And so, of course, I also want to give them. They did make discoveries, and is where it's that first part of the name, which I'll use the transitory based. And then on top, one's very scary so far.
But we appreciate it looking.
And we appreciate things like this wonderful comet. So the two observatories.
And it's especially different groups thing because
Right.
then they can verify each other's findings, which makes us that much more confident.
In January, in China, never first sighting. They and it didn't get to that point. A month later in February, project was able to confirm that comet. We've been following its journey ever since for the last year and a half. Hard, but,
And when this comet was so far out in our solar system, extremely faint. They didn't have this lovely tail and this big bright coma to find it. So
exactly. Really come from. So it's Oort clouds. That's OOT. It's a relatively mysterious part. We're still trying to figure out, like you said earlier, we've never actually seen anything in the Oort cloud with our eyes. We made that long journey.
So if you think about it, we got the planet on the outside edge, and that's the beginning of the between Mars and Jupiter. And then there's the comet belt that we call the Kuiper belt. It's an entire belt of beyond Pluto. The Oort cloud is outside of that.
Right.
So think of it as this entire sphere of objects. But those objects of our solar system, they formed in our solar system. These objects are part of the material that made Jupiter and made Saturn. And early in that process, these are like pieces. They're like part of the solar system, and they're just orbiting the sun.
Right.
And every so often, one of them's orbit gets diverted, and it comes visiting. And this is our newest visitor.
Exactly. One in a long series of comets that have made their way into the inner solar system, graced our skies with these beautiful views. Now, I do want to be conscious of your time because I got to get here soon. So it has been lovely having you with me here, Cora.
Thank you
so
for letting
fun.
me join you.
Chatting, observing, chatting the comet with you. You know, it's been something that has been so exciting the last couple of weeks to get
I was
to.
so excited 2 days ago when I got my first pictures of it.
Oh,
So
I know.
I kind of had a geek out moment.
It's
It was way
hard to
fun.
resist. You know, you might think that as people that do this stuff a lot, that are frequently involved in astronomy, that the magic fades a little
Yeah,
bit.
you would be calm, cool, and collected, but no.
Clearly, neither
It
of us
was-
are calm, cool,
yeah,
or
no,
collected.
No. We
at
had
any
way too much
time.
fun.
Right. And you know, I think that's something that I love. I wonder that it is able to generate
And
in
something
you.
new all the time.
Oh yeah, and this comet has been such a great example where, you know, there are always things that surprise us, and seeing these new things is always so exciting. Well, thanks so much for joining me
It was my
tonight,
pleasure.
Corey.
Anytime.
Oh yeah,
And I'm gonna go stare at some stars.
exactly. Enjoy staring at stars
Because it's gotten really dark now.
and
It's
doing
awesome.
lots more of sitting here doing, showing people how
And
they
hopefully
can observe.
everybody can go outside there and check it out.
Exactly. You know, we showed you those stellarium views because we want you to go look too, right?
Right.
And so you're catching the comet on your own.
That's
All right.
it. All right. Thank you
Thanks
so
for
much.
All right. Well, now while we're doing this comet observing, I did want to talk a little bit more about this object. It's been such an exciting one, and I wanted to show another image that I got a few nights that I captured with a very different type of light from the sky, collecting it in a big piece of glass, and if the camera were not on, you could put your eye to it. Now this one was captured with a very different kind of telescope. This one is called a C-Star, and this is a new class of telescopes that we refer to as smart telescopes. So these are telescopes that are only used for imaging. They have no eyepieces on them, but they are able to stack images together, much like astrophotographers do, to create the beautiful astronomy images that all of you are so familiar with seeing at home, right? And so this is taking a lot of that really hard, intensive processing work and doing it totally on its own. And one thing that I really appreciate in this is seeing all of these different parts that make up a comet. So here, that really bright core, I'm gonna mouse over things a little bit here. This really bright core is what we call the coma. And this is the tight inner part of the comet that is this big ball of gas and dust that is around the actual nucleus, which is the comet itself. Now, the big part that we were seeing in that other live view before, and what we're seeing go backwards, is the tail of this comet. Now, you might think, oh, that's the path that this comet has been taking, that's the journey that it followed. Shockingly, no, that is actually being pushed backwards by solar radiation. And so, you know, we were mentioning the power of the sun earlier, right? Now, the reason I brought this picture up is I wanted to point out a really interesting thing that we were able to spot with this comet. So frequently they'll have two tails. They'll have a gas tail and a dust tail, but those will both be in generally the same direction, being pushed backwards. Now, these are really fine particulate, really little pieces of rock that are being pushed backwards by that solar radiation. But what we have here is, it's faint to see in the image. I think the next one that I have here, actually I brought the contrast up a little bit, where you can see this distinct, what is called an anti-tail here. Now, this anti-tail, you can also call it a dust trail, is actually showing the orbital path that this comet has been taking. These are larger bits of dust. Now, when I say larger bits, we're talking about sizes about the size of a grain of sand, maybe small pebbles. They're really still very small, but they're just heavy enough that they are not being pushed backwards by the solar radiation, and instead are showing that orbital path. And that was one thing that we can never predict if that's gonna happen on a comet or not, what the tail will look like in advance. That is all up to, you know, how this comet is going to produce it, how it breaks up when it gets close to the sun, how close it gets to the sun, so many factors that can influence that. And that was one thing that was really particularly special with this comet today. Now, I hope all of you were able to catch it at home. It has been so wonderful having the comet up, and I do encourage you, if it's clear tonight, take your chance while you got it. This is getting further and further from the Earth every single day. It's getting dimmer and dimmer in the sky, so take your chances while you can. Get outside and catch this comet. Well, my next segment, we're gonna take a little bit of a break from the telescope observing, and I'm going to bring somebody on that is a little different from the other folks that I've had so far. Everybody else has been from Southern Illinois University, but next I'm actually gonna bring on an amateur astronomer that is a part of the Astronomical Association of Southern Illinois. This is Jan Treese joining me today. Jan, would you like to introduce yourself a little bit to the folks at home?
Oh, hi, I'm Jan Treese, and my husband is the president of the Astronomical Association of Southern Illinois, so they call me the First Lady.
Oh, well, I am so honored to have the First Lady here with me today. You know, Jan, it is always such a joy to get to talk to you and everybody in the astronomy club down here. Every time we come down to Southern Illinois, you guys are always there alongside us at every one of our programs, helping us with telescope views. And, you know, amateur astronomers are such an essential part of star parties, right? And bringing this community together. And so I thought, you know, it would be such a bummer to come all the way out here and only talk to professionals. You know, we got to talk to people that are really putting their boots on the ground, getting these telescopes out there for the folks. So I wanted to just talk to you a little bit about your time in astronomy. I know Harry's really brought you into this world, and you have really dove in head first. So what got you started in astronomy to begin with?
Well, being married to him, and you know, he's been in the club for about the club's about 27 years old, and he's been in it from the beginning. And in the beginning, I didn't participate because I had my own things going on. But the last 20 years or 15 years or so, I've been involved too. And it's a really great organization and a great place to meet people and to do the stars and get to work with you and Michelle.
Oh,
and
that's very kind of you.
Yeah.
We always love getting to see you guys when we're down here, and it's also a really important part of what we do at the planetarium. Always on our Sky Observers Hangout shows, we're shouting out all of our huge slew of volunteers that love to come out and help out with us and do all of this observing. And it's really, I don't know if other scientific fields have this because I haven't been such deeply involved in them, but seeing the way that passionate people like yourself and everybody else in the astronomy clubs really connect with it is always so wonderful. And I wanted to shout out the little logo here on Jan's jacket. Jan's always there getting the word out about the astronomy club at all of the events and really sharing things with people. Now, one thing I always love to ask people when I'm out with them is, I think one thing that is wonderful about astronomy is the memories that it creates for you, right? And those can be community-focused memories or astronomy-focused memories. But I want to hear about one of your favorite observing memories that you have. Some of your favorite times out with the club.
Okay. Well, my favorite is always the first time I saw Saturn. It was like everyone else that sees Saturn. Is that really a picture or is that really Saturn?
I know, it is such a special moment, right?
Each time you see it, it's just wonderful.
I know, it's one of my favorites. I've really been enjoying, we were just pointing out that it was visible up in the sky tonight and talking about it. And, I've been loving having it. Such a joy to share it with people. And you said how magical your first time.
It is.
Now, it's an eclipse, and of course you were lucky for the eclipse back in April. What was it like?
This year we chose to stay home. It was the first eclipse. This one was just, it was just magnificent.
When they sent it to us, and I was getting choked up watching a little place that we were renting. It was me and my It's such, It's such. I think it really shows. You folks joining us online that Star Party to astronomy. If astronomy as a hobby, what would your answer to?
By all means, I've talked to in order to be an astronomer or to go out and look up at the sky.
Absolutely. We were talking about things like constellations, right? Doesn't require the fancy tech, though having folks like 30
bigger Adler
is wider than the one only people stopping us from saying we have the state AAS and I mean a big part of that is getting folks to look through your telescopes. Yep.
And once
exactly. Well, Jade, I appreciate you mentioning. Actually, if you want to talk a little more about no matter where they are,
we are part of what is called the library. Currently, in 9 libraries where we have telescopes. One of the libraries has out just like. They loan them out just go in and it's very card in those 9 towns. Get a lot more towns going to make telescopes to the library.
Here to Southern Illinois, I know in Chicago we have a lot of the surrounding suburbs. Across in the world, exactly. So you're joining from, barrier to entry, right?
Right.
And it can be really intimidating. Having these available things, you get hooked, then and start some things, but coming to parties like this, loaning those, so many great started, and I really appreciate you bringing that up, because we're all about bringing astronomy to the masses as easy as possible,
We are,
right?
and as
Making
cheaply
it
as possible.
accessible. Sky of all of us every night, not, you know? But being able to share that with everyone is always so exciting.
It is
and
exciting.
I love getting to talk with you guys. Telescope that's better than mine. Look through it. It's so cool, and I love it up. And coming down here to Southern Illinois, you guys are a really big part of that.
And we love having you and Michelle both.
So, thank you so much, Shannon. Have a great rest of your night with the Observer. I'm sure you guys have been having a blast.
There and help.
I must one day, okay?
Thank you.
Right, well, for a bit of additional telescope observing, and continue to looking at some objects now that we're starting to get some darker skies here, and we're starting to be, you know, we wanted to focus on the comet earlier, but you know, we wanted to focus on the comet here because it was going to be tough to spot as the night went on, as it dips down lower. But we've got tons of other objects taking as it gets darker, and as we're able to see, was something that I wanted to make very prominent in the sky, and something that you might be able to take a look at. We show this view of Saturn that was taken through one of our telescopes at the Planetarium, but also I wanted to, if you've got be able to spot Saturn right now. It's up in the sky, it's super visible, and there's something really interesting that's been going on with Saturn recently. So this image was taken a couple of years ago, and you'll see that these rings are really nicely tilted to the side. They're very visible. You can really see that Cassini division. Well, recently, this thing has tilted almost spring up here for us here on Earth. And so this is a really interesting opportunity that, you know, only comes around once every few years, and has been really fun to watch. And Saturn is an exciting place right now. You can spot a lot of its moons, and it has some of the most interesting moons in the solar system that I always love to talk about with folks. So some of things like, or some of these other moons, and one mission that really to the intricacies of these moons and these other worlds in the solar system. And so this was one that made flybys of Saturn, made moons around it comes from, and one particularly important one was the. So this is one handed down to the surface of Titan, sending us the first images back from one of these moons, other than our own, and such a stunning image and a place to visit again. We have a mission, a Dragonfly spacecraft, which is almost similar to a helicopter that has been, you know, now really taken off since sending the Perseverance and Ingenuity, the helicopter to Mars, that has been doing a spectacular job, flew so many more flights, really, really successful. That has been a really, and is really is going on make it there too far from now. So that is a really exciting one that we are looking forward to in the coming years. Well, Saturn's an easy one to observe. Advantage of some wonderful imaging telescopes that we have, and spot some of the more difficult to view targets. Guest up with me, Richard Danley, who I think should be around here in the dark somewhere. Sorry, I can't see anything behind the light. observing. Richard Danley has been doing. I think it would be great for you to introduce your involvement in the project here at SIU.
So, my name is Richard Danley. I am the lead of the astrophotography. Last year, right around Eclipse, back use telescopes and take images very, very quickly, and we did. We had a great show come out in April. But I taught everybody, so I stopped there. And the part about SolarSTEAM is to continue on the project. And so that's what.
Right, we had Harvey open to chase in the future, and you know, of course, those skills beyond. I think we should get to observe. You guys have been doing an amazing, pulling some beautiful images tonight. I've been sitting over here seeing them on screen every once in a while.
On the ground, running cables all evening, and
exactly.
It's good.
Couple of days of practice and really good. So, do you want to introduce us to this first object that we have here in our sights right now?
So this is the Lagoon Nebula. I can't remember if it's an emission. I believe it's an emission. I believe it's light. Dust in the background and then reflecting back to us instead of emission nebula. And I believe it's a which
is how large, right? The estimations for the tail that I've seen were upwards of like 10 degrees.
Yeah.
To give you some perspective, the moon is a degree across, right? So that is an object in the sky, and we were getting a ton of that tail. So seeing the filling the field of view, this is one that's well known as a nebula that can't, especially if you're using things like binoculars, right? And so one is, wow, just a view, and I love seeing all of those. And this one is nebula. That light inside of it. You know, a little bit, I want to mention what this word. I mean, a whole bunch of.
Yeah, you basically have it down. Is that it means a big cloud of. They thought other galaxies were nebulas just because it's space. It's a nebula.
You'll see these different terms that they didn't really know looking at when they made these names. But one of my favorite examples is always how we refer to these big dark lunar Greek word for sea, right? Because they thought they were literally looking at them up in the. And it's really uncover the mysteries behind it.
So again, we usually often use those definitions. It's not quite correct anymore.
Right. We're kind of stuck with the terminology. Exactly. The term, and we make lots of distinctions earlier and comparisons to filaments and how they're really the exact same object, slightly differently, right? Now, one question that I have about this. I don't know if you'll know the answer to this, but something that has piqued my interest is I'm seeing some dark patches in here. So this one down here, this one here.
So those are not actually part of the nebula. Actually, issues with our camera.
I was wondering if those were camera things or what. That's what I wanted to ask and familiar with them.
If we ran corrections on the camera, we're running fast tonight. We're not taking amazing what it is right now.
I actually think that brings up a great point because we were talking about I was talking about the Sea Star on the show earlier and how much it has gotten to this big, complicated, really simple one that has happened. It would be a great folks about what really does happen for astrophotography, because I think a lot of people aren't very familiar with astronomy. They see these beautiful images. Oh, that's what it looks like, right? But there's a lot of what processes are you doing to create those beautiful pictures?
For these, well,
I know these ones are simple. If you were really going all out right now, we're of these out quick and dirty. Feels like a star party, right? Test things, steps that are involved in.
A lot of several minute exposures. I think these are running at 50 seconds. We would be taking 5 minutes with very little gain, so there's minutes. And we would take those and we'd take a lot of them. Probably run the whole night, and then we would stack the images together.
Right, and I want to reiterate just this object.
Yes.
Right? Looking at different things, looking at one
object. And we would stack these together, and by that you can take one image and you put the image over top, and you put the image over top again, and eventually those little details come out. Your telescope coming in, or your camera coming in, and you out by subtracting stuff and dividing some stuff,
right?
With your flat frames, dark frames, and everything like that.
Exactly. Right. And so they're correcting for familiar ring that you'll see in the bottom. A piece of dust on or something like that.
But
it'll drive you crazy. And about these do is that's really important to know is that they are magnifying, providing a zoom of objects. Right?
No.
What the telescope?
Telescope is to collect. That's all to collect light. 7 millimeters across, depending on how. Compare that little. And it when visually it's going to bring it down into a very, very small area that your eye can actually interpret. Things. It's these things that are very
right. That's another really big one, right? Is it's I don't know what frame rate is, but it's some tiny amount of milliseconds. Right? It's super quick. That allows us to see everything. Right. I'm very glad vision does work that way. So different from a camera.
Yeah. So for the Lagoon Nebula, what we have up, you would see a hazy patch in the sky. And even if you were just running at the same frame, it's still going to look cloudy just having that long exposure. And that's the kind of the astrophotography and a telescope.
Right.
Is able to set those. You're able to set exposure time, and it allows to pull in all of that data. It's often people and drama on the side of the telescope, and you're not going to see a hazy patch in the sky, which is great. Sometimes you can.
Yep.
But you need to have realistic.
This is a really big part. Objects that I think look like the planet. They're so incredibly. I mean, the moon's incredible. Fails to impress, and then some of these other brighter objects, things like nebula, can be really beautiful. Things like that, but there are some of these like really massive, very dim objects. But it is always my favorite example because one thing is the Andromeda moon in the sky. The only problem is that it's too dim, right? And larger to build them up, and over here today is demonstrate very similar principles using light waves. This is utilizing sound waves, right? Over to just our camera view for a second. Into a tube. Worried that this wouldn't work as well as I thought it was going, or as well as this together. And I went all the way over to the door, and I was like, all right, I can barely. And I was like, better. Right? And that is the exact, just a big mirror and a couple of other little mirrors in different places, right? Do such a beautiful job of collecting, all of this extra light so see these kinds of objects. Might have some other stuff.
We do
tonight?
have M13, the Great Cluster Nucleus.
I love this one. This is one of my favorites to observe, and a really beautiful view of this. So, Richard, do you want to give us a little intro as to what we're taking a look at here?
Which you are cluster or globular, depending on how you want to pronounce it. And these are, there's a little over 100 of them within. Can't give you an exact number, but what these are very tight balls of stars. A few, smallest ones a few 100,000, the biggest ones a few million stars in a very, very tight area. So if you look closely, you'll see some high defined area is millions of stars. Many are too dim to see. There's many ones in this region that is the overwhelming light that you see out of the cluster.
Right, and so are suspected to be almost like dwarf galaxies that were forming around the outside of the Milky Way. So the Lagoon Nebula that we were looking at earlier, and all these nebulae that we observe within the galactic plane itself, right? This is something that is actually outside of that galactic plane, orbiting around the core of the Milky Way. A lot of different places. Actually, I have a map here that shows us globular clusters. So I have imagery, one of the most up-to-date, high-resolution maps of the galaxy that we have, or at least from our, and all of these globular clusters. I love seeing really where these are placed. They form this big kind of sphere. That's why you'll often find we were talking about with that with Stellarium earlier in the Lagoon Nebula, of course, being in Sagittarius. These kinds of objects. So I want to get back to our beautiful view of.
If you go back to that real quick.
Oh yeah. And the Gaia imagery.
And
Southern Hemisphere was actually really disappointed. Blocking my view. It's the Andes mountain range. That was what was to the west.
Can't do anything about that one.
No, can't do much about that. And it was a little bit past prime viewing season for them, so that was a little bit disappointing to lose out on. Yeah, so some really beautiful sort of dwarf galaxies that orbit around. Can you get M13 back, the globular cluster? That'd be awesome. There we go. Perfect. Thank you. So we'll shift back to our live view here because there's still a lot of really interesting stuff that I think we can talk about with these globular clusters. So one thing that we have found in these is that they have a really high percentage of very old stars, and I think this starts to reveal kind of the formation of these objects and how they came to be, right? Is these are dating back to really early times in our galaxies. They're very old objects, and so the only stars that we see remaining are these really old ones that remain.
Stars like the sun, maybe a little bit younger, maybe a little bit older. If you go into astronomy and astrophysics, you'll learn things like HR diagrams that'll tell you where the turnoff point is for ages of stars and everything like that. And we can look at these and determine, judging by each star that's in there, we can kind of get an idea of how old they are just by the age of the stars and the brightness of them and what stage of life they're in, by looking at these clusters, and they are very old. They're billions of years old, and they're still staying in a nice tight ball that they formed in when they came out of the same gas cloud.
Right. Oh man, it's just incredible, and I love it. I love comparing the different globular clusters, and especially if you get a really magnified view. I might have another picture of it in here. If you get like a big magnified view like this, which was through the 24-inch scope that we had up earlier, you can really start to make out some individual ones and get better information about all of these different ones, right? Taking a look at their spectra, even just the color of these stars can start to reveal things to us, right? You'll notice you don't see a lot of like blue tinted stars in an old globular cluster like this, because those are stars that are burning really hot, really bright. That's what gives them that blue color.
And they usually only last a few million years.
Exactly, they fizzle out pretty quick, right? Or at least pretty quick relative to star terms.
On an astronomical time
On an astronomical time scale. There's a reason we use the term astronomical, not just to describe things in space, but also to describe very grand things, right? And so, some of those shorter-lived stars, we're not going to find those in these globular clusters, and I think it's so interesting to know about that. Now, one other thing that I wanted to mention, because we have, while we've used some words like some terms for this, like the Great Cluster and Hercules, we also might have been dropping some terms like M13,
Yes.
right? And I think it would be good to explain to folks a little bit what that is really referring to, what that means.
Yes. So M13 is over the past few hundred years, we've had different astronomers that have created kind of their own catalogs, and there's you can look online how many catalogs they are. There's many, many, many.
So many of them, right?
Any object that people label M whatever is going to be from Charles Messier or Messier. Again, depending on how you want to pronounce it. Charles Messier was a comet hunter, and he made
Right.
a list of 100, and there's a little bit of debate on the exact number, a little over 100 objects in the night sky that he specifically identified as not comets, and
Right.
we're not of great interest to him.
Exactly. I love the way that this catalog has come about, is that he was writing them down so that he could avoid them.
Yeah.
And then, I mean, look at what this catalog has blossomed into today. I mean, people utilize this as a starting point for observing deep sky objects,
Yes.
right? Taking a look at things outside of our solar system and really kickstarting it. And people even do the Messier Marathon, where
Yes.
they try to look at every single one of the objects in a single night. It's really taken over the kind of amateur astronomy field these days.
And it's tough, but it's doable. But
It's hard to get them all in
It's
May.
kind of fun to do.
I'm definitely not at that level yet. I have a great respect for anybody that can pull that off in a night. But I love that story of stemming from him trying to avoid comets. Oh, lost our globular cluster
Give it a
there.
second. They
but
may have saved.
it's all right.
Give it just a minute.
Well, it's all good. But really, stemming from somebody trying to, oh, there it is, it came back. Stemming from trying to avoid looking at these objects. I mean, we took a look at a comet tonight.
Yeah.
This looks pretty different from it, but he was, of course, doing all this stuff visually with the eyepiece, and it's all those faint fuzzies like you mentioned before, right?
The telescopes you buy today are going to be much, much better than what he was working with. So to him, these were just little tiny blobs in the sky that really didn't have a whole lot of detail, and he would observe them, and he's like, it's not moving, it's not a comet, I'm going to go look somewhere else. It's only in the modern times that we're just like, hey, the stuff that he didn't want to look at is what we do want to look at.
Yeah, it's actually really
So,
interesting, cool stuff to see, right? And, as we were talking about earlier, comets don't come around super often, especially not bright ones that are really nice and visible. And so the Messier catalog, all these things are always around, which is really nice, right? Now, I wanted to check and see if we've got any new feeds coming in other than these couple of objects. If not, I had some images pre-saved.
I haven't moved them over to anything else yet.
Anything else? Well, if you, it has been wonderful having you with me, Richard. If you would like to go and catch some new targets for us, we've still got some time taking a look at things. Maybe get Andromeda in view.
We're definitely going to do Andromeda. I think I can get a good image of Andromeda.
I think that would be great. Any other kinds of like planetary nebula, if you want to give them a shot, would be a lot of fun. And then we'll be ending the night off with a little view of the moon, which is just, I could just barely start to see it coming over the trees right there.
There's a tent wall in the way, so I can't see it.
You'll see it soon. You'll see it soon, but we'll catch that towards the end of the night. So, Richard, it has been such a joy having you on here. Thank you for providing us these magnificent telescope views tonight. We really appreciate it, and your insights have also been really wonderful. So, thanks for coming on and sharing that stuff with the people here. All right, thanks so much for coming, and we're gonna keep rolling with how we're observing here on the stream. So, this globular cluster has been great, but I want to take us to look at a couple of other objects that I had brought up tonight, just in our journey of taking a look, and we'll see if any of these, while he's getting set up on some new objects, we'll see if any of these come up later. So, once you move beyond the solar system, where we have the really obvious objects, things like the planets, the sun, the moon, these things that we're very familiar with in the night sky, we start to get into what is called these deep sky objects. So these are things in the galaxy that extend beyond our solar system. So these are all those faint fuzzies that Richard was mentioning, right? And so these are things like nebulae, other galaxies themselves. Another one that is included in there is like those globular clusters, right? These are all these deep sky objects that are really the next step after you learn about all of these solar system objects. After you start to observe those, the next step is always to take over these deep sky objects. Now, we were mentioning the really wide range of nebulae that there are out there, and some of my favorite to observe are something called planetary nebulae. Now, this is another one that is a little bit of a misnomer. These, in fact, are not planets. As I mentioned, these deep sky objects are all things outside of our solar system, and we can't spot any planets outside of the solar system from here on Earth, at least not with standard telescopes that you would be looking through. Only a very few select exoplanets have ever actually been directly imaged before. So what we are taking a look at here is a planetary nebula, and they're called planetary just because they kind of look like a planet. That was the thought process anyway, and so you can imagine why they might have thought that. They have these very distinct, crisp edges, they're very colorful like a planet is, but learning about what these actually are is, I think, even more interesting and exciting to hear about. So how these planetary nebulae are formed, and this picture can start to give us a little clue of that, or maybe even this next one does an even better job. This is one called the Ring Nebula. And what a planetary nebula is this is evidence of some of that life cycle that a star takes, right? We were talking about the life cycle of stars in globular clusters, just like us and everything else in nature. They go through this cycle of birth and then eventually death, and we can see that evidence in a lot of these nebulae. So planetary nebulae are particularly from kind of average sized stars, ones very similar to our sun, and they are this large cloud of gas and dust that this star sheds towards the end of its life. So eventually is not able to, the gravitational pull bringing all this in is not able to continue to maintain that. It grows in size to a red giant, eventually sending this material outwards. Now, observing these planetary nebulae is really fun because these are actually pretty short-lived objects. They don't last forever. They're in the time range of just a few, like, tens of thousands of years. Really pretty brief compared to everything else that we talk about, right? We were talking about this astronomical time scale earlier. These objects actually live a little bit more on an earthly time scale, at least, just maybe 10-20,000 years. Now, some other things that I notice when looking at this planetary nebula here is the beautiful different colors that we're able to get from this. And these colors can reveal a lot. And I think the dumbbell in particular really gives a great view of these different colors that we can spot in a nebulae. So you'll see these kinds of red areas that I think give it that dumbbell name, right? These red shapes around the outside, extending across the middle. And that red color is coming from sulfur and nitrogen that was ejected out from the star. The blue and green colors that you'll see, and those are really common in them. This picture doesn't bring the color out quite so much, but you can see a little bit of that blue here in the center with the red ring around the outside. And that blue is coming from oxygen that the stars are sending out. So all of these different things that are kind of these leftovers as the stars are expelling things out. Another thing you might notice is that those stars do still remain, but they reach this very different stage of their life called the white dwarf stage. I think that really stands out well in the Ring Nebula, where you don't have a lot of this nebulous gas and dust in the way. That little star right at the center of the ring, right in the middle of the donut, is actually the white dwarf that expelled all of this material out. So interesting to see all of those different details that you can spot there. Now, another thing that we'll be observing, which, it looks like they're starting to get it in view in their telescope. I know they're probably still in progress over there, but I'm going to switch over to it because it is already looking beautiful. This is the next object I wanted to talk about. This is the Andromeda galaxy that we are seeing here. Now, this is the one galaxy that is, a full galaxy outside of the Milky Way that you can technically spot with the naked eye. It will take we lost it there a little bit, but it's just taking another image here. This is the one galaxy that, from a very dark site, you can actually see with the naked eye. So this is our nearest galactic neighbor, and there's actually a lot of people talk about this story of Andromeda potentially making its way over here. Well, we lost Andromeda there for a second, but that's okay. I'm gonna cut back over to my slides here for just a moment. Oh, it's all good. No, it's just working out the telescope views. Catching a bunch of new objects is pretty tough. And so they are working on getting those in. Richard was really downplaying how difficult astrophotography is, how difficult getting these images is. There are so many different settings and things. That's good for now. Yeah, thank you. That's the one I was going to talk about for a little bit here. And it might go black every once in a while. It's just because they're refreshing a new frame. That's okay. Exactly. Yep. So basically, what he has to do is he's balancing out all of these different things. So exposure time, gain, all of these different settings that go into being able to produce these images to get the best views possible. So I'm going to start here with an image of Andromeda that I had taken previously. Actually, this was just from maybe a week or so ago through the sea star that I had mentioned earlier. And this is really taking a look mostly at the galactic core. So he was able to get a much wider field view through his telescope, take a look at the larger galaxy itself. And while we're on this topic of galaxies, I want to talk a little bit about the types of galaxies. So you might notice when you look at pictures of Andromeda, like this one, you'll see this kind of familiar spiral shape that we think of when we think of the Milky Way galaxy. And this is a very common type of galaxy that I think we're most familiar with, something that we think of first when we imagine galaxies. There's actually a pretty big world of galaxies out there. So this map is from Edwin Hubble. I'm sure you're familiar with his name, probably primarily through the Hubble telescope that was named after him. But he was a professional astronomer that made a whole bunch of really revolutionary discoveries and did a lot of great work for the astronomy community. And he also was able to document this or create this classification scheme for different galaxies. So Milky Way and Andromeda Galaxy are actually technically classified as these barred spiral galaxies, these bottom ones where they have a part that comes out a little bit more straight from the center and then starts looping around. But you'll also notice these other very different ones, the elliptical galaxies. And these ones are almost more like large, massive balls of all of these different stars clumped together. Oh, sorry, I'm getting distracted by every little updated picture that I get of the Andromeda Galaxy. It's very exciting. This is such a fun one to observe. And so there really is a pretty big range of galaxies out there. And you know, I think something that you'll notice as we talk about all of these different objects today, as we mention, you know, these different things that things like the comets, things like, so sorry, I keep getting distracted by my monitor over here. Things like the comets, you can tell, you know, the universe isn't perfect. You know, I know for us here on Earth, where we have these very consistent days and seasons, it feels very perfect and exact all the time, but really there is a whole range of, you know, there's so many things moving out there, influencing each other in so many different ways, that there really is it's a complex world out there, right? I think something that makes it seem a lot simpler to us here on Earth is that they're on such grand time scales, right? But these things are really very complex, and there's a huge range of kinds of galaxies, ways that they interact, ways that they form. You know, it's a really big universe out there, and uncovering that piece by piece is what's so exciting about astronomy. Now, while we talk about Andromeda, and actually I'll swap back over to camera 3 here because we are starting to get another little view of the core of that galaxy there, is talking about the future for the Andromeda Galaxy, and maybe actually the future of the Milky Way galaxy as well. And you know, whenever I mention this, or like the sun dying, which it will eventually, it'll engulf the Earth, you know, I always have to remind people this is happening very far in the future. Do not worry. But Andromeda and Milky Way are very close together, relatively, and as far as galactic terms, right? That is why it appears so bright in the sky, why we're able to get these beautiful views of it. And so what is actually happening is they are slowly drifting towards each other. And as time goes on, eventually these two galaxies will collide, interact, and it's really, as far as astronomy stuff goes, it's not so far, only 4 to 5 billion years from now. Now, while these galaxies do look very dense and compact when you're looking at them like this, there's really a lot of empty space in between the stars, right? The nearest star to us is 4 light years away. We got a lot of room in between us and any of the stuff far away from us. So it'll be a slow collision. It's not gonna be things like a bunch of stars smashing into each other like you might imagine. More than anything, it will be a very gradual kind of shifting of the shape of the galaxies, right? And they will go from, you know, really they're kind of these barred spirals that have these big long arms coming out of them with this dense, tight, compact core in the middle. And those shapes will get all kinds of topsy-turvy. They'll spin around each other. It will be, you know, I imagine a really interesting sight for folks in other galaxies in the future. If there's any aliens out there taking a look at us in 5 billion years from now, they will have a really interesting view of Andromeda and and the Milky Way interacting in that way. Now, I like talking about this name Milky Way because it really shows how all of these names were stemming from just what we were seeing in the sky, our best guesses of what we were looking at, right? And the Milky Way, right, and this term galaxy really stems from how it appeared across the sky, right? Now, if you are in a bright place like Chicago, it is very difficult to view the Milky Way, right? You might see a few stars, those sorts of things, but you're not really gonna spot the big band of the Milky Way passing overhead. And actually, if I shift back, I don't wanna make anybody sick by shifting through my slides too fast, but if I come back to that view from Stellarium that we had up earlier, you'll see here, there's this path coming out of Sagittarius's teapot, this, well, Milky Way going across the sky, right? It's this fuzzy, kind of cloudy patch that spans across the sky. And so we call this the Milky Way really because it just, that is how it appeared in the sky, right? It's really, we describe these things exactly as we see them, right? We find out later that this is actually the core of the galaxy that we are looking at, right? So it has that bright central core near Sagittarius that we are looking at, and then these thinner parts that extend out in other ways. And you can really see that in that Gaia view that we had up earlier as well, imaging the entire galaxy here, right? So I'll take away the globular cluster bright yellow dots, right? And you can really start to get an idea of the form of this galaxy, that shape, right? Hand back over to our live telescope views that they're working on getting some more objects in here. Oh, looking beautiful, always so fun to observe. I hope that anybody that's joining us online is able to get outside and do some observations of their own. There's tons of really fun objects to be looking at tonight, from things like Saturn and the moon that is coming up beautifully now here in Carbondale, all the way to other dimmer objects like the Andromeda Galaxy that we're really starting to get into view here. It's looking extra nice now. So I love in this image, you can see that really bright core, right? And that bright core is very telling of how galaxies form and kind of their general shape, right? Is at the, ooh, yeah, now they're brightening it up a little bit. That looks great. So in this core, at the center of all of these galaxies, or at least our best guess is what's at the center of all of these galaxies, it's held pretty true when we've been looking at the cores of galaxies, is typically supermassive black holes. So you might have heard of black holes before. They are huge, well, they're actually not particularly large all the time. They're usually quite small, but very, very dense, heavy objects, so heavy that they are pulling everything in, including light, right? Even light traveling so fast is not able to escape the core of these galaxies, right? And so what that means is that those galaxies, they are holding that entire, or those black holes are holding that entire galaxy together. So just like here in the solar system, we've got the massive sun in the middle, right? 1,000,000 times the volume of the Earth, right? With all of these smaller bodies orbiting around it. Same with the galaxy, right? We have these massive black holes in the center with all of these different stars orbiting around it, much less massive than that central black hole. And so what you'll notice in these images of Andromeda, like this one, is that we have this really bright core where tons of stars are being brought towards the center, attracted by the really massive gravitational pull of that black hole at the middle of the galaxy. And then the rest of them, just like the planets are orbiting around the sun, the rest of these stars are orbiting around the outside, right? So even our sun is orbiting around the core of the Milky Way galaxy. We're pretty far out, so that period is many millions of years, right? It takes a very long time to make it all the way back to the beginning. And what that means is that, that is all of these objects out in space are constantly moving. Everything's really in motion and always changing. And something that's so interesting about astronomy is the way that all of these objects are very dynamic and fluid and in motion together. Okay, sorry, I had to catch my breath there a little bit. It has been such an exciting night of observing. I hope you all have been enjoying catching these objects with me tonight. Wanted to bring us back to our live view of Andromeda tonight. And one thing I want to point out here is we can also see down in the bottom right corner, actually another little friend making an appearance. That is not technically a part of the Andromeda galaxy, but is instead, just like we were seeing in that Gaia image earlier around the Milky Way, some of these little side galaxies, these dwarf ones that are orbiting around it. Do you have any other objects that we could take a peek at? Yeah, thank you. Oh no, now we're over to the Ring Nebula. You were on Andromeda before, so this is actually a live view of one of those planetary nebulae that I was talking about earlier, and wow, I'm really impressed. One thing you'll notice is that these objects are pretty small. The Ring Nebula is very far away, and this is a very wide field telescope. Oftentimes you would use different cameras for capturing something like the Ring Nebula versus something like the Andromeda Galaxy, right? The Andromeda Galaxy covering a very large part of the sky, and the Ring Nebula taking up a really little portion of it. So in my image that I had shown earlier, this was through a 24-inch telescope, right? So really high magnification, it's got a long focal length, whereas this view through the telescope right now, much smaller telescope, not so much magnification. Like I said earlier, that's not always the goal, right? But one thing that I really appreciate in this is how vibrant those colors are, and how beautiful the star field all around this is, right? There's so much to see here in this image. And just as a reminder, this is the remnants of essentially a dead star, one that is not producing energy anymore through fission like is happening in a star like our sun, right? Inside, there's so much pressure, everything's bouncing around so fast, the individual atoms are actually fusing together. Sorry, I might have said fission earlier, I meant fusion. They're fusing together, creating new atoms, right? And so, towards the end of their life, as these elements get heavier and heavier inside of the star, they're no longer able to fuse these together anymore because they're it takes a lot of energy to fuse them together. So what that means is that they shed these outer shells, and this is their real late stage part of their life. Now, one thing that I am excited to observe tonight, if we can catch it before the end of the night, is the moon as well. If you could let them know that I would love to have a view of the moon if it's visible to them tonight. I know it's just starting to come up. I can see it breaching the trees over there. Hey, Bob, welcome back. Welcome back. Yeah, hop on in. Yeah, come on in. We're just doing a little thing.
That's pretty cool.
Hang out for the last 20 minutes. I know the moon's looking beautiful. We've got the little Ring Nebula here in sight now.
See, and I was looking at that and I was like, hey guys, on the Ring Nebula, and I saw it in color, and Richard swapped out the camera for a color one. It was cool.
I know. This one I was noticing how vibrant the colors are, because I was showing to folks online this view that I'd gotten from the Adler, where we can really get a lot of detail, see that white dwarf at the center of it.
Is that the 14-inch?
This is 24 inch. Yep.
Yeah.
What can I say? Yeah, we got the 24-inch plane wave there. And so that larger telescope helps us bring out some of those details. But I was really impressed by the color that we were getting in this.
That's beautiful.
Through the scope out here tonight. And we had observed so many fun things earlier. We looked at the Lagoon Nebula. We were taking a look at M13, a globular cluster, talking about all these different things. And one thing I think it would be great to chat with you about, Bob, while you're here is, we waited until it was dark outside to look at these objects, right? Because these dark skies are really, really important for observing these distant, dim things, right? Yeah. And so, this was something that we mentioned a little bit at the beginning of the show, based on this location that we were choosing, right? Mm-hmm. And so talk a little bit about why you guys chose this spot, what dark skies really mean to astronomy, and I mean, we can talk a little bit about how we're kind of losing them these days, right?
Yeah, actually. So we chose this spot based on a few things. First of all, it's relatively close to the university, and we knew we wanted to use it for our astronomy labs.
Right.
And it's only a couple miles, but it's in the middle of a section, and what I mean by that, a 1 mile square section, and we're right about in the middle of it. The other thing is we came out and did site survey a few times. Andy Edelin, who was the Astronomical Association of Southern Illinois Club president at the time, we came out and surveyed it a couple nights, and just we noticed fog would roll in repeatedly, and we're like, I don't want to be down there. this is a little bit of a plateau.
Right. Oh, that's so interesting. Well, we were just dealing with these kinds of geographical considerations earlier this week on Tuesday when we were doing a comet show on the Adler's YouTube channel. It was really cloudy at the museum, so we went to my boss was a little further away from the lake. It was nice and clear over there. Interesting one that I wouldn't have thought about out here.
Yeah, it's just all these, and it's dark. As you can see, it's relatively dark.
Yeah.
You don't see the headlights from the road. You only see them when you come down.
Nice woods shielding a lot of these things, right?
Yeah, and so when arms about, they were like, "Well, we'll clear it out. We'll clear it out." I'm like, "No, leave it.
Don't clear anything.
Leave it."
That's great
because it's such a great barrier for us.
Right.
The other thing, the driveway that you see here, that's original to the Jackson County Poorhouse, which used to be located out here, which was a place where people went to retire when they didn't have any other place to go, or if they were poor and they needed a place to stay. So over by where you see the big screen, that's where the house was. And then this driveway, we knew that it was good and solid. So we the house was torn down a long time ago, and we brought in we poured the telescope pads out here, like I said, on the driveway where the house is. And we had bigger plans for this. We wanted to put a observatory, permanent observatory out here, possibly a planetarium.
We've got out here tonight every time. I know I've said it's if you.
I gotta
certainly
check
get
it out
over there. I would love to show you.
It's bright, I bet.
Hey Richard,
compared to
do we have any
things.
other views that we could pop Andromeda back into there? I think that ready to soon. That would be awesome. Oh.
About this is like on the roof of the Neckers building, the roof of our physics building there. See this stuff, but maybe once or twice a year.
Oh, full black hole. Even being able to see really pretty lines for spirals, right? Oh wow, look at that. Applause to the telescope crew
Nice
over
job.
there. You're doing such a great job. It looks spectacular. Seeing some of these other that orbit.
Tell you how he's doing. He's running right now.
Yeah, we're the process of astrophotography and how much. Of course, he's not the really post-process. And getting this level of awesome and using some beautiful scopes. I mean, I don't know.
These are
make some great
like about them. Different filters in them. Hydrogen. We took the Australia because we didn't have to pay and white.
Right.
It's all in one filter, and you can do nighttime observation, which they did out here. And I always tell the guys, and I'm like, put that in a bag.
All of this glass.
Yes. There's perfect, and guys, here you see it. We definitely notice it in Australia. Pinpoint.
The glass that they're using is incredible. Based out of Arizona. Scopes, the visual observing one of their H alpha scopes at the planetarium, and for their size, really do blow me away every time I object that you had in view over there. Wasn't effects earlier because it was when we were looking at the lagoon. I was like, I want to know.
And I'm just
is this part of the actual object, or is this part of the camera? And
it's probably, I don't think it's, but it might be something that we could have removed with a flat field or something, which we're not bothering with tonight.
Right, exactly. We were about some of those in-depth processes that you go through. So that dark you see kind of in the top right corner of this is that is not a part of that actual object.
Right.
just a part of the, difficulties of imaging this stuff, right?
Yep.
Stuff gets in the way,
And-
there's little dust,
And it's
weird
a live
problems with the
stack.
chips.
It's a
and-
live stack.
Exactly.
Taking the dark, calibrating the images. In post-processing, that would come out. You just see the image. And the other thing, processing is we put color filters on this and take all different images to make a full color. But for us, especially when we take science images of the sun, we're not really interested in colors. We're interested in the different levels of light, bit depth of our cameras.
Right, exactly. And if we're going to use a color camera, you often don't get quite as clear of a resolution, right? It might make a pretty picture in that one shot, but you'll really get much higher when you're taking these white cameras and these individual and stacking them. And I'm glad we took a look at this. We had taken a look at the moon earlier, and we've seen a lot of these things in it's the sky, the core of the galaxy. I know earlier Corey was talking about the tea pouring, all the steam coming out, right? And so it's this really busy region, really tightly packed, right? And so we've got all of these big sort of clouds of gas and dust. These kinds of big clouds are important in the creation of all of these new stars and things, right? These kinds of things can collapse back together. This isn't for these nebulae are really a for work,
Well, I'm really students are doing over here tonight.
I know. Up to I think this is 6 different objects that we've observed already. Scopes, really exciting.
And
maybe.
So part of our SolarSTEAM group, undergraduates who've been part of the project now. Gosh, we're a couple of years.
Yeah, I know, right?
Kidding me?
Wow! Holy cow!
What?
That's the DEB
with a Neptune C. So, Richard,
us that are American and don't know millimeters that well.
An astrograph. I believe it's a triplet. So it's which means it's a very sharp scope, like this, that are color. Richard said this was a Neptune C, which the C stands for color. Neptune's a small chip. So the Neptune are what we took our images of the with the coronal with. But what we've told our DEB groups, and we have, by the way, across the country, some of them imaging tonight.
Yeah, and we went from a dynamic Eclipse broadcast to
well,
dynamic astronomy broadcast. It's expanded to so much more.
We're doing the daily solar observations. We're looking at doing an Eddington experiment, just not to. We're not adding anything to the experiment. It's just kind of a fun thing to take a star field image and compare it back to those coronal light bending around the sun, like Eddington did. But this is like
I'm blown away. Sometimes it's right, and just getting familiar with it, taking a lot of time. Best and man, I am so this picture in particular, and the fact that it was that little scope that pulled this off is amazing.
It's an auto. There's no post-processing being done on that.
Oh man, another one. They are working overtime over here right now. I talked about this one a little bit earlier. We got the Dumbbell Nebula now too, another planetary nebula.
Wow.
Right, and really, really vibrant colors here. Those bright blues from the oxygen that is expelled out. Those deep reds around the outside, giving it that dumbbell name.
Yeah.
From the sulfur and nitrogen that was contained inside of this star. Wow, really beautiful
guys,
views.
They're running 4 telescopes. We've got 3 mounts with 3 lunts on them, and one of the DEB scopes is piggybacked on them, and so that's how they're able to do this. They're able to move to another object is piggybacked on them, and so that's how they're able to do this. They're able to move to another object while keeping one object on target for us.
I mean, they are working hard over there. I've had it easy. I'm just sitting here in the seat talking. That's an easy job. They're over there working away on the telescopes, getting us these beautiful views tonight, and we've been so lucky lucky that it has been so clear tonight. We've been blessed with some great weather. I know some of the DEB folks that were joining us from other places that I think of as maybe more clear than Illinois.
Typically.
Typically, right?
Yeah.
Have not had so much luck. So it feels like Carbondale has really been astronomically blessed in the last year. We've gotten so many great opportunities for observing.
Oh my gosh, the
right?
aurora was incredible.
Oh yes, I know. We were talking about the sun earlier and Heliophysics big year, and you can definitely tell it's solar maximum right now, right?
Yeah.
Yeah, absolutely.
Getting towards the end of it, and the end of it usually has the better aurora displays, so it's exciting. But yeah, did you talk to Carla tonight, by the way?
Not particularly on the show, no. But
I'm bringing it up because Carla's brought several media arts students into this as well, and so these feeds that you're seeing coming through, this isn't just physics undergrads sitting around. We've got the help of media arts students. This is a new type of thing going on.
Right, I mean, that was something I talked about with Harvey, is how I love the multidisciplinary approach that you guys have really taken with this project, and how many different kinds of people are involved in this work, you know?
It really is campus-wide. When we talk about interdisciplinary often, you know, people think, well, I'll just call up my friends, we'll work together. I'm like, we're reaching out, we're working with a lot of people that we haven't worked with before. And not just here, at different locations. So I know Dennis, who is one of the DEB volunteers.
Target that I was hoping to end the night off with. Thank you to my wonderful telescope team. We had to wait until the end. It was rising a little late tonight, but a lovely view of the moon. And you know, I want to point out at home where to really focus on and see the most detail here. It's along something called the terminator. So the will flash. It must have been getting taken. Getting the focus better. Exactly. So this terminator is this line along that you see on the bottom in the image here, and so this is part of the moon where it is going from time, right? This is on those areas of the moon they're experiencing sunrise or sunset, right? And one thing I always mention to people observing the moon is, what is it like when you're here on Earth around sunrise or sunset, right? These long shadows. Well, on these long shadows that I really think helps highlight some of these details in the craters, right? And something that makes observing the moon always so fun and exciting is that, you know, you can go out during all of these different parts of all these different phases, and really see different details so strongly. And
it's stunning. It's better when it's not a full moon. So
right. So a full moon is almost too bright. You don't have any of those details really.
There's no shadows. There's shadows and there's craters.
Right, exactly. It's like you know, noon here on Earth, where you know the light's shining right down on you.
Straight on you.
Exactly. It's really hot. Yeah. But you don't have very much shadow, right? So.
Yeah. So when people think about this, and the image from the sun, kind of from the side of this and the top.
Right. Exactly. You can imagine coming from the top left, that lit, right? The shading at the bottom, not confused with like a lunar eclipse. Have the shadow of Earth passing in front of it. This is really just the moon can ever be lit at one time, right? That's the half that's, and the part that we are seeing, the amount of that change, right? So that's how we get this range from new to full moon. And I wanted to send folks away with my last little, I apologize to any of the parents at home. I also apologize to my hotel. Earlier, I cleaned up very nicely in a less mess than I was expecting, which you'll get to see soon. But one thing that I love in the details here is we've got this huge crater that side of the moon, Tycho crater, right? And one thing that I love seeing from that is those huge lines that extend out of the center of that crater, right? So you have the crater in the middle, and then these big ejecta patterns expanding outward. And so this shows you a little bit about how these craters are formed and why these patterns are happening. So I'm going to pull up. It smelled like I was making brown in my room when I was doing this earlier. But you take a tub, do a layer of flour on the bottom. This flour is representing the lunar subsurface, right? The moon that we are seeing. A dusting on top and sifting to do this. Because I used cocoa. And this surface, right? All of these rocks that top of the crust of the moon, most of the stuff that we're seeing there. And now, I'm not sure this worked earlier in here, so I'll put you back on the video saved on here because I was worried it wasn't going to work. And gosh, I made the mess in my room. I better play out, right? To make, right?
Yeah.
So out in space, that's things like the rock that I'm far from an and crash into it. You can see not so much that got on the table. It wasn't bad at all. It's not so far from the impact craters that we see on the moon. That this one took, which can't happen, but they're traveling so. Love the way that this brings of that those big patterns.
Yeah, it just blows out.
Exactly, right? It's lifting these things from underneath the regolith and Coco.
Massive. You're talking miles.
Many. See, everybody always asks, oh, the Lunar Reconnaissance Orbiter can see those. We can make it as like 2 miles with the 24-inch scope. And today, if we get our view of the moon, finish us off for the night. Thank you so much. So, really encourage people to go out and look at because this is such a great naked eye target, right?
Yep.
It is, always exciting and beautiful.
Everybody can see it now.
Exactly. Everybody can see it right now. It's that we all share,
Except
right?
maybe way out west.
Maybe way out west. Yeah, I don't know how late it is. 7 o'clock. It might be.
But yeah, it's a great naked eye object. This is one of the first objects I ever looked at. And
like through a telescope?
Yeah, it is the first. And I remember
it was definitely the first time. Middle. All right, I got to start a little easier.
So I just got to have a track. Yeah.
Oh no, absolutely not. No,
so
a little tabletop Dob that's like $100 probably.
Remember how quickly the moon just?
Well aware. I think the moon and the they move their entire diameter in like 2 minutes.
Yeah.
Makes it, when I do my public events, and all the folks out here with annual telescopes, makes it really hard on you. You gotta cycle.
It is.
You gotta check it and moving.
Yeah, I remember seeing, like I was zoomed way in on it. You had to just keep up with it fast, and then realizing, okay, what's going on? That's not the moon just zipping. Although the moon's moving.
The moon's moving,
the
but
Earth.
it's the Earth. Right? You're really connect yourself with the big universe out there when you observe these things, right? I think, it just takes a closer attention to them to really appreciate all of those little details, right?
Yep.
Now, well, one thing I wanted to finish the show with is you guys here at SIU with SolarSTEAM, what you have coming up.
So, total lunar eclipse. In 14. To do this again.
Well, that's on the future too. I think we'll be down here with you again doing some streaming for
SolarSTEAM. That's one of our that we're doing. One of the things we're doing. Keep going. Quite a while. We have them. We have
on the YouTube channel. If you want to catch any, that right here on these. These different astronomers with a bunch of experts from SIU's campus.
And then keep with the DEB Initiative and DEB Initiative doing daily solar observation now. So if people look at ERA, just simple spell. You can see observing we're doing. It's interesting because there have 1 or 2 observers. Got like 5, 5 at a time. But you can get on there and see they're live and they're uploaded, and what we're is to observe a flare telescope and right. So our citizen science happens like when I satellite so that they know that we or we
it's material out there. Whether or not that that material is going to interact with us, a little bit harder. Yeah.
It does.
It's nice that it takes a little. Exactly, right? So it's at least. Any other?
That's the
I'm
main
sure,
thing.
I'm sure there's some eclipses in your
we're
distant
looking
future.
Oh my gosh, we're looking forward to
28, 23.
Spain is a good opportunity to do some training for the bigger one, the bigger total solar eclipse, 2027.
Right.
So
clear
Africa.
Skies in North America.
It goes over a larger amount, and the
Yep.
eclipse is higher. So that's the next step for DEB to do our coronal observations. Is look at
Sound like they're going to cross for the lunar eclipse.
Yep.
And we'll be down here doing a broadcast really similar to this. We have a series called Sky Observers Hangout that for Planetarium. The upcoming shows. I'm super pumped. Looking, and that is such an exciting mission. Really taking a look at all of the different things that all of the different worlds that are there, and the intricate mix that we have everywhere in Europe. And if there's anywhere we're going to find life, I feel like it's there. Anywhere. So that's such an exciting mission, and hopefully you can join me for the stream in December. I want to leave thing to look for. I mentioned technically in a meteor shower tomorrow night. Eminids later, really spectacular. And it produces tons.
Early December,
yeah, but time for it. And check a lot of some meteor showers like that. They really extend the period. We're also getting into season, getting to observe Jupiter and Saturn is exciting, and getting some of those winter kind of certainly a favorite in Orion that is just starting to rise.
Yep.
These later hours of the night now.
Photography, that's a great.
And actually, one of our other Sky Observers Hangouts was all about observing different objects in Orion and talking about kind of the life cycle going from birth nebula to be a future death with beetles. So, any final words to the folks at home?
Joining us. We have turnout out here. I think we're up to about 400 people coming through.
Oh, that's awesome.
U.S. join.
And it was our first year. We might have had a few technical difficulties here and there. National Star. We're just even us tonight. We're with the of some, and yeah, I hope you appreciate those. I'm getting a sneak peek now in our next. For joining us. Have a good one, folks.